For centuries, Mars was nothing more than a reddish dot in the night sky, a constant and mysterious light that even before modern science awakened an almost spiritual curiosity in ancient civilizations. The peoples of Mesopotamia called it Nergal, the god of war and destruction. The Romans named it Mars, patron of strength and conquest. The Greeks saw it as Ares, symbol of blood and rage. Since then, humanity has associated it with war, life, and death. This imagery persisted for millennia, until in the 19th century, the advancement of telescopes turned observation into something more than myth. It became a scientific window to another world. And it was precisely at that point that fascination intensified, when the unknown began to gain visible contours and the line between science and imagination became dangerously thin. With increasingly precise telescopes, 19th century astronomers began recording details of the Martian surface. Among them was Giovanni Schiaparelli, an Italian astronomer who in the year 1877 observed something that would forever change how the red planet was seen. He described fine, long lines crossing the surface of Mars, which he called canali. In Italian, the word meant natural channels, but when translated into English, it became canals, carrying a much more artificial meaning. This simple linguistic difference ignited popular imagination. If there were canals, someone must have built them. Thus arose the hypothesis that Mars harbored an advanced civilization, perhaps older and wiser than ours. That idea was embraced with fervor. The American astronomer Percival Lowell devoted much of his life to studying Mars and defending the existence of those artificial canals. In his private observatory in the Arizona desert, Lowell produced detailed maps showing a complex network of lines stretching across the entire planet. To him, that was no work of chance, but the result of alien engineers trying to save their dying world, transporting water from the polar caps to the equatorial regions. The narrative was poetic, tragic, and profoundly human, and therefore deeply convincing. The myth of the Martian civilization began to take root in the collective imagination, fueled by the press, by novels, and by the hunger for an inhabited universe. While scientists debated the validity of these observations, writers transformed mystery into literature. H.G. Wells, in his classic The War of the Worlds, published in 1898, described a Martian invasion of Earth. It was no longer just a scientific hypothesis. It was a mirror of the human condition, a reflection of the fear that we might be next to vanish. Wells's fiction used Mars as a metaphor for the arrogance of the colonial powers of the time, but it also fed popular terror. If they were there and we were here, the encounter was only a matter of time. The public believed. People looked up at the sky with the same awe their ancestors felt upon seeing an eclipse. And the name Mars ceased to be merely that of an ancient god. It became the possible address of another humanity. Even when Lowell's observations were contested, especially after the more precise measurements made by E.M. Antoniadi, who proved that the canals were optical illusions caused by telescope limitations, the myth did not die. In fact, it took a new form. If there were no artificial canals, there might still be microscopic life. The red planet, cold and arid, seemed dead, yet not sterile. On the contrary, the absence of certainty only fed the fire of imagination. For many, the farther the answer, the greater the hope. The turn of the century brought with it the birth of astrobiology and spectral observation. Scientists began measuring the atmospheric composition of Mars, and although they discovered it was much thinner than that of Earth, they still found subtle hints of something more. Color variations on the surface were interpreted as Martian seasons, and the appearance of dark patches suggested to some the presence of vegetation. Science oscillated between caution and enthusiasm. Each new piece of data was a spark that rekindled the dream. But there was also a psychological component to this fascination. The 19th century was the era of colonial expansion and great geographic discoveries. European empires advanced over unknown lands, and each new map seemed to confirm that the world was conquerable. Mars was simply the next territory. If Earth had already been mapped, the cosmos remained. This mentality of scientific conquest blended with mystical and literary imagination, turning Mars into the symbol of a new frontier, the final frontier, the new world that would replace the old one. And this romantic vision was not harmless. The belief that other planets existed only to be studied, conquered, or transformed was, in essence, an extension of the same mentality that had already devastated entire ecosystems on Earth. The gaze upon Mars was a gaze of power, not of contemplation, but of domination. The red planet became a mirror of our own desire to control what we do not understand. As observations continued, the technological advances of the early 20th century began to lift the veil of fantasy. Larger telescopes, sharper photographs, and spectroscopic instruments revealed a barren planet, devoid of oceans and almost without a breathable atmosphere. Yet even in the face of these findings, the public did not stop dreaming. Popular culture had already adopted Mars as an eternal symbol of hope and mystery. The myth was too alive to die, and perhaps that is the deepest point of all. The myth of life on Mars was never only about Mars. It was and still is about us, about the human desire not to be alone, about the need to believe that the universe holds more than silence. To look at the sky and imagine life beyond Earth is, in a way, to look inward, into the restlessness that drives us to explore, create, and challenge the limits of reality. The fascination with Mars is the reflection of the human soul searching for meaning. When Giovanni Schiaparelli pointed his telescope and saw those faint traces upon the reddish disk, he did not discover a planet. He revealed a mirror, and since then, humanity has never stopped seeing itself reflected in it. When the 20th century established itself as the age of space exploration, Mars ceased to be a distant dream and began to become a destination. The advancement of aerospace engineering during the Cold War turned the red planet into a field of scientific and symbolic competition. Nations did not only want to dominate space, they wanted to touch another world. The space race began with the launch of the artificial satellite Sputnik in the year 1957, and the arrival of humankind on the Moon in the year 1969 marked the height of this competition. But while the eyes of the public were turned toward the silver glow of the Moon, the most visionary scientists had a different obsession. Mars, the planet that for centuries had been legend and metaphor, was about to reveal its true face, and with it, perhaps, the greatest existential shock in human history. Between the years of 1962 and 1976, the Mariner and Viking missions became the first concrete steps toward the exploration of Mars. The Mariner series of probes developed by the North American Space Agency opened the way. Mariner 4, launched in the year 1964, carried out the first successful flyby of Mars in July of 1965. The images it sent back were shocking. For the first time, humanity saw up close the surface of the planet that for centuries had inspired dreams and fears. And the reality was very different from the colorful fantasies of lost civilizations and seas of living sand. What appeared in the photographs was a desolate desert, covered in craters, with no visible signs of water or vegetation. A dry, cold, and silent world. These images, which today may seem simple, had a devastating impact on the collective imagination. They destroyed at once the romanticism of Lowell, the tales of Wells, and the optimistic visions of Martian life. The disappointment was deep. For decades, the planet had been portrayed as a possible second Earth, and suddenly it appeared dead. But scientists knew that this conclusion was premature. Mariner 4 had flown over only a small portion of the planet, and the extreme conditions of its surface did not necessarily mean that life had never existed there. On the contrary, some researchers began to argue that Mars might once have been far more hospitable, perhaps with rivers and seas that dried up over billions of years. The search for life did not end, it merely changed shape. In the following years, new Mariner missions were sent, and with them knowledge began to expand. Mariner 6 and Mariner 7 in the year 1969 brought high-resolution images of the polar caps and the complex topography of Mars. They discovered canyons, mountains, and regions that suggested ancient geological processes, perhaps shaped by running water. Then came Mariner 9 in the year 1971, the first probe to enter Martian orbit, and it was Mariner 9 that revealed for the first time the grandeur of a world in transformation. When it arrived, a global dust storm covered the entire planet, preventing the surface from being seen. For weeks, all that could be observed was an orange disk without detail. But when the storm dissipated, a spectacle appeared. Immense dry riverbeds, colossal volcanoes, valleys as deep as open wounds. The largest of them, Valles Marineris, over 4,000 kilometers long, was named in honor of the mission itself. That vision changed everything. Mars was not just a cosmic graveyard, it was a planet that had lived. This discovery rekindled hope. If Mars had once had liquid water, it might also have harbored life. It was the bridge between past and present, the missing link between two worlds. And it was this spirit of curiosity that motivated the next step, not just to observe, but to land. Thus were born the Viking missions, definitive milestones in the history of space exploration. Viking 1 and Viking 2 were launched between the years of 1975 and 1976, carrying not only cameras and scientific instruments, but also the weight of a question that had spanned centuries. Are we alone? When Viking 1 landed on Mars in July of 1976, there was absolute silence. The entire world watched the transmission. For the first time, a machine built by human hands had landed on another planet and sent back clear images of its surface. Rocks, sand, horizon. The emptiness was almost poetic. The probes conducted pioneering biological experiments designed to detect signs of microbial life in the soil. There were 4 main tests involving gas exchanges and chemical reactions with radioactive nutrients. And then came the result. Ambiguous, disconcerting, almost philosophical. One of the experiments, called the gas release test, indicated possible biological activity. The soil seemed to react in a way similar to living microorganisms on Earth. But other tests did not confirm the presence of organic compounds. The Martian soil contained highly oxidizing chemical substances that could simulate biological reactions without involving life. The final verdict was suspended between two worlds. Perhaps there was life, perhaps not. No result was able to close the debate. And ironically, this uncertainty fueled the mystery even more. The images sent by the Vikings showed a cold planet, orange in color, with a yellowish sky and a melancholic horizon. It was beautiful and solitary, as if time itself had stopped. Even without direct evidence of life, scientists understood that the world had once been dynamic, perhaps fertile, and certainly more complex than they had imagined. Fascination with Mars was reborn, no longer as the planet of gods or the home of lost civilizations, but as a natural laboratory of life's own history. These missions also marked a new kind of scientific thought, caution regarding contamination. Before the Vikings, little had been said about the risks of carrying terrestrial organisms to another planet. But the possibility of polluting Mars with microbes from Earth gave birth to the concept of planetary protection. It was the beginning of the awareness that, in exploring other worlds, we could also destroy them. This realization would forever change the way science viewed the cosmic frontier. By the end of the 1970s, humanity had achieved something deeper than images or data. It had found a mirror. Each photograph of the Martian surface showed not only the desert of another planet, but also the inner desert of our own existence. And the question that guided scientists became less, does life exist out there? And more, what does it mean to exist in such a vast and silent universe? Mars remained there, motionless and mysterious, awaiting the next human attempt to decipher its secrets. The era of the probes did not bring definitive answers, but it inaugurated a new way of thinking. Understanding the cosmos required humility, and perhaps the first step toward understanding Mars was accepting that it never promised us anything. We were the ones who projected all our dreams upon it. At the dawn of the new millennium, when the dust of the space race had already settled, and humankind once again looked to the sky in search of purpose, Mars called again, not with the brilliance of a conquest, but with the whisper of an unfinished enigma. The Viking missions had left open questions, and a sense of uncertainty that echoed across generations of scientists. Had we missed something? Could there be, hidden beneath the cold reddish surface, some trace of microscopic life waiting to be rediscovered? Science, now more mature and cautious, decided to restart the journey, this time with electronic eyes capable of seeing the invisible, robotic arms that would touch the Martian soil, and precise instruments that could analyze what once seemed undetectable. Thus began a new era of exploration. Between the years of 2000 and 2020, a sequence of missions redefined what humanity knew about the Red Planet. The first great adventure of this cycle was led by two tireless explorers, Spirit and Opportunity. These twin rovers were sent with a clear purpose: to seek evidence that Mars at some point had liquid water, the most essential element for life as we know it. The success of previous probes had shown the path, but the definitive proof was still missing: unmistakable geological signs of a wet past. Spirit landed in January of 2004 inside Gusev crater, a plain that scientists believed to be an ancient lake bed. Its twin, Opportunity, arrived a few days later on the other side of the planet, in a region called Meridiani Planum. Expectations were high, but no one could have imagined what would come next. Just 3 weeks after landing, Opportunity sent back images of tiny spheres embedded in the rocks, formations that scientists nicknamed blueberries. They were composed of hematite, a mineral that on Earth forms in the presence of water. That discovery was a turning point, literally. For the first time, we had concrete evidence that Mars had once been, billions of years ago, a wet planet. Meanwhile, Spirit, on its arduous journey through rugged terrain, also found clues confirming the suspicion. Mineral deposits altered by water processes, rocks fractured by ancient hot springs, and geological structures suggesting the action of flowing water in the distant past. But what impressed the world most was the endurance of the two machines. Designed to last only 90 days, they defied all expectations. Spirit operated for more than 6 years, until it became trapped in a sand dune in 2010, and Opportunity worked for nearly 15 years, sending back more than 200,000 images. Its final transmission, poetically interpreted by the mission engineers, read, "My battery is low and it's getting dark." The entire Earth wept. These missions rekindled the hope lost since the Viking era. They showed that Mars was not a static desert, but a planet with history, scars, and geological memories of a habitable past. With this new knowledge, the next step would be bolder, not merely to search for indirect signs, but to analyze the soil and atmosphere directly with miniature laboratories. Thus was born the Curiosity mission, the most ambitious robotic explorer ever built. Launched in 2011 and successfully landed in August of 2012 inside Gale crater, Curiosity represented the pinnacle of human engineering. It carried high-resolution cameras, a complete chemical laboratory, and even a laser capable of vaporizing rocks to study their composition. Its destination was chosen with precision, a crater that, according to orbital images, contained sedimentary layers from an ancient lake. As the rover climbed Mount Sharp at the crater's center, it revealed a story written in stone, a sequence of clay, sulfate, and mineral deposits that, on Earth, are formed by prolonged water presence. Mars, at some point in its past, had been a blue world. But the discoveries did not stop there. Curiosity detected complex organic molecules and seasonal variations of methane in the atmosphere, a gas that, on Earth, is often associated with biological activity. Although not definitive proof of life, the fact that methane fluctuates with the seasons suggests active processes beneath the surface. The planet, seemingly dead, still breathes in some mysterious way. Meanwhile, new orbital missions such as the Mars Reconnaissance Orbiter and Mars Express map the planet in unprecedented detail, revealing networks of valleys, deltas, and hydrated minerals. Each discovery reinforced the idea that Mars, billions of years ago, was a world of oceans and a milder climate, perhaps even with an atmosphere dense enough to sustain rivers and rain. The sequence culminated with the arrival of Perseverance in February of 2021, carrying aboard the small helicopter Ingenuity, the first human-made object to fly on another planet. The landing in Jezero crater was historic. Scientists chose this region because orbital images showed a fossilized delta, an ancient river system where water once deposited mineral-rich sediments. Perseverance's main mission is to collect samples that will eventually be returned to Earth. This goal, known as sample return, carries a deep symbolism. It is the final link between dream and danger. Bringing material from another world means opening a new frontier and also a new risk. What all these missions have shown together is that Mars is a dynamic world, with a wet past and perhaps a more active chemistry than we ever imagined. It may not harbor forests, oceans, or civilizations, but it holds in its soil the traces of something greater, the reminder that life in any form is stubborn, It leaves marks. It endures. It changes the worlds it touches. Yet there is also a silent irony in all of this. The closer humanity comes to understanding Mars, the more it realizes that the true mystery is not out there. It is within us. The desire to colonize, explore, and transform another planet may reveal less about the universe and more about our own nature. The fascination that drove Schiaparelli, Lowell Wells, and so many others was never just scientific curiosity. It was the desire for transcendence, to break cosmic isolation and prove that we are not solitary travelers in this ocean of stars. The mission's spirit, opportunity, curiosity, and perseverance are, in truth, chapters of the same story, the story of a being that refuses to accept the void. They roam a desert of stone in the name of hope, carrying with them a question as old as time itself. What if the universe is still alive? From the beginning of the 21st century onward, the exploration of Mars ceased to be a purely scientific project and began to acquire tones of corporate, technological, and ideological ambition. The Red Planet, once seen as the boundary of human knowledge, began to be treated as a business goal, a territory to be conquered by those with courage and capital to try. The dream of colonizing Mars did not appear suddenly. It is the result of an accumulation of frustrations and hopes, the perception that Earth is moving toward an ecological crisis, the fear of extinction, and the almost messianic desire to find a new home. In this context, space stopped being the unknown and became a market, and among all its possible frontiers, Mars became the ultimate symbol of the technological promise of the new millennium. The major space agencies, such as the North American and the European, had spent decades studying ways to send humans to the planet, but they constantly ran into monumental challenges. The distance between Earth and Mars varies from 55 to more than 400 million kilometers, depending on orbital position. A one-way trip can take between 6 and 9 months, requiring spacecraft equipped with life support, radiation protection, and resources for an extended stay in an environment without air, without liquid water, and with average temperatures of 60 degrees Celsius below zero. For a long time, it seemed impossible. But in the early years of the 2010 decade, the discourse changed. The arrival of private companies in the space sector turned utopia into a business plan. Among these companies, one stood out as the bearer of an almost religious vision: SpaceX. Its founder, Elon Musk, declared that humanity's destiny was to become a multiplanetary species. According to him, colonizing Mars would not be merely a choice, but a necessity to ensure the survival of civilization. In that narrative, the Red Planet was a kind of plan B for the environmental and political collapse of Earth. This idea resonated strongly in an age of global anxiety, marked by climate change, pandemics, and energy crises. Suddenly, Mars became the ideal refuge, distant, pure, and promising. The technological proposal seemed bold and irresistible. SpaceX began developing reusable rockets and the Starship system, designed to carry cargo and humans to Mars in large numbers. The plan was to create a self-sustaining city of 1 million inhabitants by the end of the century. Solar energy, oxygen production from Martian carbon dioxide, cultivation of plants in pressurized greenhouses, and mining of subsurface ice to generate fuel. All these concepts moved from laboratories to public presentations and timelines. What was once science fiction became a corporate goal, but the enthusiasm also brought a new kind of debate. To what extent is it ethical to treat another planet as a resource to be exploited? The idea of terraforming Mars, artificially heating it, thickening its atmosphere, and creating conditions for terrestrial life, is both fascinating and alarming. It assumes that we can manipulate an entire ecosystem, even without knowing whether it already harbors its own forms of life. It reflects the same mindset that devastated forests, oceans, and atmospheres here on Earth. Colonizing another world is not a neutral act. It is the transplantation of an entire civilization, with its virtues and its vices. Meanwhile, other nations were also advancing with their plans. China launched the Tianwen-1 mission, which entered Martian orbit in the year 2021, and successfully landed the Zhurong rover. India, the United Arab Emirates, and Japan also joined the race, each seeking to consolidate its presence in the new stage of cosmic exploration. Mars became once again a political stage, but now power was no longer measured in ideologies, but in data, patents, and orbital territory. Within traditional agencies, the debate intensified. The North American agency created the Artemis program, designed to test technologies on the moon before taking them to Mars. The goal is to establish a continuous line of human exploration from lunar orbit to the Red Planet. The European and Russian agencies developed the ExoMars program, aimed at detecting ancient biosignatures and preparing the ground for future crewed missions. The difference is that for public agencies, the focus remained scientific. For private companies, the focus was colonization. That duality will define the future of human presence in space. The corporate discourse, wrapped in motivational campaigns and promises of technological immortality, wins over crowds. It speaks of changing humanity's destiny, being reborn on Mars, starting again from zero. The rhetoric is powerful because it mixes hope and fear. The fear that Earth will not endure, and the hope that Mars might forgive us. This combination creates a collective imagination of escape, a new exodus. But deep down, the question that echoes is simple. Are we taking the best or the worst of ourselves there? The colonization of Mars is not just a scientific experiment, it is a confession of failure. In dreaming of a new home, we admit that we have destroyed the one we already had. The Red Planet is the mirror of a humanity tired of itself, trying to start over without healing its own wounds. Every project of a pressurized dome, every plan for terraforming, every simulation of a Martian greenhouse is, in a way, an act of despair disguised as achievement. Yet there is beauty in that impulse. The ability to dream, to look at the impossible and attempt to reach it, is an essential part of what makes us human. The same hands that build rockets are those that write poems about the sky. And perhaps, in the balance between technology and humility, there lies a chance to learn from Earth's mistakes before repeating them on Mars. The corporate dream of colonizing Mars is, therefore, a living metaphor. It shows both the brilliance and the arrogance of the human species. While it represents the pinnacle of our engineering, it also reveals the abyss of our self-sufficiency. Perhaps we will be able to land there, build shelters, grow plants, and breathe manufactured air. But what will we do when we realize that the emptiness of Mars is not only outside? Since humankind began to dream of Mars, the Red Planet has taken on a role that goes beyond the boundaries of science. It has become a symbol, a spiritual and psychological mirror of what Earth can no longer provide. The idea that Mars could be a new home is not only technological, but deeply emotional. It represents the desire to start over, to erase the traces of the destruction we have left behind, and to rebuild the world on a clean canvas. It is an imaginary refuge where humanity believes it can free itself from the guilt accumulated on Earth. This idealization did not begin with modern rockets, but has been growing as a narrative of collective redemption. Colonizing Mars, in the contemporary mindset, has become a metaphor for purification, a cosmic exodus toward lost innocence. In popular culture, Mars has always been the stage of the possible. Films, books, series, and even songs have shaped the image of the planet as a mirror of human destiny. In every generation, the Red Planet has assumed the role that humanity most needed to project. In the 19th century, it was the home of ancient and wise civilizations, a reflection of the hope that the universe held superior knowledge. In the 20th century, during wars and the space race, it became the enemy, the invader, the other, the alien. In the 21st century, however, the narrative reversed. Now, we are the invaders. Humanity no longer fears the Martians, it fears itself. The dream of colonizing Mars is, at its core, an attempt to escape its own shadow. Collective psychology sees in Mars a stage for projecting our deepest fears and desires. When we speak of saving humanity by going to Mars, what we are really saying is that we have lost faith in ourselves here. The promise of a new beginning out there is a palliative for the sense of ending that hovers over the blue planet. Pollution, global warming, mass extinction, inequality, and water scarcity. All these symptoms of Earth's collapse feed the myth of Mars as a lifeboat. The idea is simple and dangerous. If we have ruined this world, we can start another. And it is precisely that logic that turns the dream into a risk, for it reveals our refusal to change behavior before changing address. There is an almost religious dimension to this fascination. Mars is described as the inverted Eden, a dead place that must be revived by human hands. The discourse of colonization is wrapped in messianic language, saving the species, planting life where there is none, lighting a new flame in the universe. Humanity, in this context, no longer sees itself as part of creation but as the creator. The figure of the modern explorer merges with that of the prophet, and technology becomes the new faith. Rockets and pressurized habitats are treated as sacred instruments of scientific salvation. This faith in technological power creates a sense of destiny, as if Mars were waiting for us, as if the very nature of the cosmos had reserved for humankind the role of sowing life among the stars. But the imaginary refuge comes with a price. It hides the fact that Mars, in reality, is hostile to life. Its atmosphere is thin, composed almost entirely of carbon dioxide. Its average temperature is below 60 degrees Celsius negative, and its surface is constantly bombarded by cosmic radiation. It is an environment that challenges all known forms of existence. Yet the human mind insists on finding beauty in the desert. The red planet seduces precisely because it is inhospitable, because it represents the extreme of challenge and the promise of transcendence. It is the same force that drove ancient navigators to cross oceans, that propelled the race to the South Pole, and that now compels us to land on a world where we cannot breathe. In a symbolic sense, Mars is the altar of human hope. Every planned colony, every imagined translucent dome beneath the orange sky, represents an attempt to redeem the errors committed on Earth. In artistic representations and digital simulations, Mars always appears clean, serene, and orderly, the opposite of the terrestrial urban chaos. There are no wars there, no pollution, no political borders. There is silence, space, and a new beginning. The planet has become a blank canvas onto which we project what we wish to be, but have not yet managed to become here. However, there is a painful irony in this idealization. The same impulse that makes us dream of a new home is the one that destroyed the old one. The desire to dominate, transform, and control the environment, the very impulse that now takes us to Mars, is the same that unbalanced Earth. When we imagine the red planet as a promise of purity, we forget that we are the bearers of impurity. There can be no purification when the agent of destruction travels with it. The risk is not only biological or environmental, but moral, to bring to another world the same way of existence that has already devastated our own. And yet, Mars remains irresistible, because it represents the final frontier of the impossible. It is the place where humanity deposits what little remains of its faith, not in gods but in itself. The Martian promise is the echo of an ancient desire, the desire not to disappear. It is the hope that even if Earth dies, the human story will continue to be written on another soil. And perhaps that is why, even knowing that the red planet is desolate, we continue to look at it with tenderness. Every night, when Mars glows in the sky, there is something profoundly human in that gaze. It is the longing for a home that does not yet exist, but already inhabits our imagination. It is the symbol of the future, not the technological future of machines, but the emotional future of a being that dreams of surviving its own finitude. Mars promises what Earth has already lost, the feeling that there is still a possible tomorrow. In recent years, as rockets return intact to Earth and robotic spacecraft traverse the Martian soil with almost surgical precision, a dangerous illusion has grown that the mastery of Mars is only a matter of time and calculation. Humanity, intoxicated by its own technological progress, has begun to treat the cosmos as a natural extension of its power. People speak of terraforming, colonizing, building cities, and manufacturing atmospheres as if they were architectural projects, ignoring the fact that every particle of that planet obeys laws we do not fully understand. Modern science, even as it proves capable of touching the stars, seems to forget what it means to touch them. Arrogance arises when curiosity turns into control, and admiration for the complexity of life gives way to the presumption that it can be recreated in a laboratory. For many of the new space entrepreneurs, Mars is a technical problem, not a biological one. They speak of atmospheric pressure, fuel transport, modular colonies, and closed oxygen systems. Life is treated as an engineering variable, something that can be calculated and predicted. But biology does not bend to human will. Mars is not merely a set of numbers and formulas. It is a potential ecosystem, with its own chemical history, shaped by conditions we still do not understand. The idea that we can simply fix the planet by heating it, introducing gases, planting bacteria, and sculpting the landscape ignores the fundamental principle of life, interdependence. On Earth, every form of existence depends on billions of others, and that network was woven over billions of years. To think we can recreate something similar in a few decades is a form of blindness disguised as progress. The advocates of terraforming often cite numbers and timelines as if nature obeyed human schedules. They speak of releasing carbon dioxide from the polar caps to warm the planet, generating artificial magnetic fields to protect the atmosphere, planting mosses and algae to initiate an oxygenation cycle. All of this sounds plausible on paper, but it ignores a deeper truth. We do not know enough about Mars, and perhaps never will completely. The mere presence of compounds such as perchlorates, which can be toxic to terrestrial organisms, already shows how alien the Martian environment is to our biology, and yet we continue to act as though the planet were an empty terrain waiting to be molded. Scientific arrogance is born from success. Every successful landing, every image transmitted from the Martian surface reinforces the belief that there are no limits. The problem is that technical success is not the same as biological understanding. Knowing how to land on Mars does not mean understanding Mars. And that is the point humanity seems to have forgotten. The universe is not a collection of machines, but of mysteries. Nature does not allow itself to be conquered merely because we have learned how to observe it. There is also a psychological component to this illusion of dominance. Humanity has grown accustomed to defeating nature, taming rivers, toppling mountains, domesticating species, and altering the climate. When it looks at Mars, it sees yet another frontier to be conquered. This mentality is dangerous because it turns the unknown into territory and the unexplored into resource. When we speak of conquering Mars, the verb carries the same historical weight as all the conquests that have already devastated worlds. This time, not of peoples, but of entire ecosystems. Planetary biology is far more fragile than human imagination. Just a handful of terrestrial microorganisms could contaminate an alien environment and destroy the possibility of studying native forms of life. That is why scientists around the world advocate planetary protection, the principle that we must not touch Mars without absolute certainty that it is sterile. But this ethical principle directly collides with technological haste and corporate appetite. While biologists warn of the risk of cross-contamination, engineers design colonies, and investors speak of interplanetary tourism. Human impatience, driven by ambition and ego, ignores the natural slowness of life. This arrogance manifests even in language. We speak of cleaning the planet, preparing the ground, installing ecosystems, as if it were possible to manufacture a world. But worlds are not manufactured. They are born, evolve, endure, and die on their own. Science can understand processes, but it cannot replace them. Trying to impose terrestrial biology upon Mars is the cosmic equivalent of planting a forest on glass. The soil does not respond, the air does not nurture, and the result is only an illusion of life. The greater danger is that, by turning the cosmos into an engineering project, humanity forgets that it is also part of the very nature it tries to control. Scientific arrogance is born from separation, from the belief that we stand above the universe, rather than within it. When Earth was the center of everything, we believed the heavens revolved around us. Today, even knowing we are just a point in immensity, we still behave as if we were masters of space. The true challenge of Mars is not technological, but philosophical. The question is not how to get there, but what to do once we arrive. If the first step is guided by curiosity and respect, the journey may teach us about life and cosmic balance. But if it is driven by vanity and haste, the same impulse that carried us to the stars may condemn us to silence. Because the universe does not punish, it only observes. And when human arrogance tries to dictate its laws to the stars, the cosmos responds with the oldest lesson of all. Not everything that can be done should be done. Curiosity has always been the brightest flame of humanity. It is what made us cross oceans, break frontiers, build telescopes, and launch probes toward the unknown. Without curiosity, there would be no science, no art, no civilization. But there is a point at which that flame ceases to illuminate and begins to blind. The desire to understand the universe is noble, but when it turns into the desire to possess it, it becomes arrogance. And perhaps no example illustrates that thin line better than humanity's obsession with Mars. The red planet is both a mirror and a warning, a reminder that our curiosity may be the same impulse that leads us to ruin. The history of humanity is a sequence of curiosities that turned into power. When we learned to control fire, we illuminated caves and cooked food, but we also burned forests. When we mastered metals, we created tools and weapons. When we discovered nuclear energy, we expanded our understanding of matter and invented total destruction. Every conquest has carried its shadow, and space exploration is no exception. On Mars, that shadow takes the shape of a silent question. How far are we willing to go in our need to know? Curiosity, in its purest essence, is a form of humility, the admission that there is something we do not know. But paradoxically, it can become arrogance when mistaken for control. The science that seeks to understand life on Mars must remain in a state of reverence before the unknown, because the unknown is alive, even when it appears inert. There is a fundamental difference between exploring and invading, between observing and interfering. The problem is that the line between those acts becomes increasingly difficult to see in an era driven by technological ambition. Mars is the exact point where curiosity meets power. We want to know if there is life out there, but the very act of searching may destroy it. Every probe, every drilling, every collected sample is also a possible contamination. Scientific curiosity, when guided by caution, is a beacon, but when driven by vanity, it is a torch in a dry field. The philosophical dilemma lies in recognizing that the same impulse that allows us to discover can also make us lose. There is, therefore, a profound ethical question. Does the human being have the right to interfere with another world? That question is not only scientific, but moral. Life, even microbial, is a sacred phenomenon in the cosmic sense, rare, delicate, and autonomous. To touch it without understanding its nature is a form of desecration. The universe has taken billions of years to create that Martian balance, and human presence, with all its technology and impatience, can alter it in mere days. Curiosity without limits is the prelude to destruction. Philosophers of science have long warned that true progress does not lie in conquering new worlds, but in understanding our place within them. The idea that the universe exists to be explored is an anthropocentric inheritance, a reflection of a civilization that still sees itself as the center of creation. Healthy curiosity is born from contemplation. Sick curiosity is born from the urge for control. And when the latter prevails, the cosmos ceases to be a mystery and becomes a laboratory. This dilemma is present in all great milestones of human exploration. Every time we gaze upon the unknown, we are tested, not in our technical capacity, but in our moral maturity. The question, can we, always comes before the question, should we? On Mars, that difference may mark the boundary between knowledge and extinction. Curiosity is the force that pushes us toward infinity, but it is also the reminder that there are things we may not be meant to reach. If there is life on Mars, it may not wish to be found. If there is none, the mere act of searching could plant our own, turning the planet into a mirror of Earth. And in that mirror, we will see reflected our errors and our illusions. The German philosopher Immanuel Kant once said that admiration and respect for the starry sky above us should inspire humility, not conquest. That phrase resonates deeply when we think of Mars. The red sky is not an invitation to occupation, but to contemplation. True wisdom may lie in knowing when to stop, in recognizing the sacred boundary between curiosity and arrogance, because in the end, the universe does not need us. It is we who need it to remember who we are. And perhaps the greatest paradox of human curiosity is this: we search for life among the stars, yet we have not learned to respect it here on Earth. Since the first steps of space exploration, scientists have understood that every journey into the cosmos carries two kinds of risk: what we take out there and what we bring back. In the excitement of reaching new worlds, it is easy to imagine space as a sterile environment, but cosmic biology was born precisely from doubt. What if it is not? Back contamination, or retrobiological contamination, is the term used to describe the scenario in which materials brought back from another planet or celestial body carry life forms, biological compounds, or chemical agents capable of interacting with Earth's ecosystem in unpredictable ways. It is a concept that exists at the frontier between fear and fascination. The possibility that something invisible, coming from another world, could alter the web of life here, where everything began. This concern is not science fiction. It was born alongside the space age itself. When the first missions returned from space in the 1960s, especially after the arrival of humankind on the moon, scientists and authorities realized that Earth might not be prepared to receive cosmic visitors. The term back contamination officially appeared in the protocols of the North American Space Agency as part of a set of measures called planetary protection. The idea was simple yet profound: to preserve the biological balance of both Earth and other worlds. That meant preventing not only terrestrial microorganisms from contaminating Mars, but also potential Martian organisms from being brought here. The foundation of this fear lies in the history of biology itself. On Earth, small alterations in closed ecosystems have already been enough to trigger ecological catastrophes. Invasive species transported from one continent to another, viruses accidentally released into populations without immunity, microorganisms adapting to extreme conditions. All of these examples show how life is resilient, unpredictable, and dangerous. Now imagine that same phenomenon on a cosmic scale. A single fragment of Martian soil containing unknown bacteria or active organic molecules could interact with terrestrial genetic chains in devastating ways. The result could be a biological event without precedent, a mutation entirely beyond human control. But the danger of retrobiological contamination is not limited to living microorganisms. It also lies in chemical and mineral structures that have never been in contact with Earth's biosphere. Molecules with unstable compositions, unknown proteins, new catalytic reactions, any of these could behave chaotically when exposed to Earth's humid and oxygen-rich environment. On a microscopic scale, the red planet might harbor forms of life based on alternative biochemistries, perhaps using elements such as perchlorates or iron instead of carbon and oxygen. These structures could react violently when coming into contact with terrestrial organisms, breaking molecular chains, inhibiting enzymes, or altering DNA. Science cannot predict how a foreign body would react within a living system that has evolved in isolation for billions of years. What makes retrobiological contamination so terrifying is the fact that it would be by nature invisible. No telescope could detect the danger before it arrived. No quarantine could guarantee total safety. Unlike a known virus that can be isolated, an alien microorganism could act in ways that our biology would not even recognize as life. It would not need to be intelligent or hostile to represent a threat. It would only need to exist. In biology, mere presence is enough to alter balance. When the Apollo missions brought samples from the moon, authorities created the first planetary quarantine system in history. Astronauts and lunar rocks were isolated in hermetic chambers for 3 weeks, monitored by doctors and biologists. The fear was real. What if a lunar pathogen escaped? In the end, the samples proved harmless, but the scare was enough to set a precedent. Since then, every mission that collects material from another celestial body must follow strict protocols. In the case of Mars, those protocols are even more severe. Retrobiological contamination is classified into different levels, and the most extreme, level 4 of planetary quarantine, is reserved precisely for the return of Martian samples. At this level, the materials would be treated as if they contained the most dangerous pathogens on Earth. They would be stored in sealed laboratories with negative pressure, multiple containment barriers, and manipulation only by robotic systems. The scientists accessing those materials would undergo long periods of isolation and monitoring. It is a precaution bordering on terror, but it reveals an uncomfortable truth. We do not know what is out there, and the unknown always demands respect. Yet humanity seems willing to take the risk. The Martian sample return program is under development, and the goal is to bring fragments of the red planet back by the decade of 2030. It will be the first direct contact between Earth and non-sterile material from another world, a historic achievement and an immense responsibility. The question is not only what we may discover, but what we may unleash. Retrobiological contamination is a mirror of the human dilemma. We pursue knowledge with fervor, but we rarely stop to measure its cost. To touch the soil of another planet is to touch the fabric of the cosmos, and every touch carries consequences. Curiosity drives us, but prudence protects us. Earth is a unique ecosystem, shaped by billions of years of isolation, and perhaps the best way to defend it is to accept that not every discovery needs to be brought home, because in the end, the true threat may not be what comes from Mars, but what humankind brings back with it. Among all the mysteries of biology, perhaps none is as unsettling as life's ability to persist where nothing else should exist. For a long time it was believed that living organisms could only thrive under gentle conditions, mild temperatures, abundant water, and a stable atmosphere. But the 20th century shattered that illusion. In the most inhospitable places on Earth, in the depths of the oceans, in volcanic craters, in toxic deserts, and even inside nuclear reactors, scientists have found microscopic creatures that not only survive, but flourish. They are the so-called extremophiles, beings that defy the limits of known life, and that may be the most important link in the search for life beyond Earth. These organisms have proven that life is not fragile, but incredibly adaptable. There are bacteria that withstand temperatures above 120 degrees Celsius, and others that remain active at 80 degrees Celsius below zero. Some live in lakes of sulfuric acid, others feed on sulfur, iron, or even radiation. Some endure colossal pressures in oceanic trenches, while others thrive in the near-total dryness of hypersaline deserts. Each of them is a victory of biology over the impossible. And it is precisely because they exist that the dream, or the fear, of life on Mars has ceased to be a fantasy. One of the most remarkable examples is Deinococcus radiodurans, nicknamed Conan, the bacterium. This microorganism can withstand doses of radiation 1,000 times higher than those that would kill a human being. Its cellular structure contains genetic repair mechanisms so effective that, even after its DNA has been completely shattered, it reconstructs it as if nothing had happened. It is found in arid, frozen, and irradiated locations, environments that, in many respects, resemble the Martian soil. Another notable case is that of microorganisms discovered in subterranean caves and subglacial lakes, living without light, oxygen, or conventional nutrients, feeding only on chemical reactions between minerals. These beings are what scientists call terrestrial analogues of extraterrestrial life. They are, in a sense, the ambassadors of the hypothesis that if life could emerge and persist in such extremes here, nothing prevents it from having done the same on Mars. The red planet, with its low temperatures, constant radiation, and salty soil, may seem inhospitable, but it holds surprising similarities to extreme environments on Earth. Subsurface rocks warmed by residual heat, ice mixed with salts, and the possible occasional flow of liquid brines are potential refugees for forms of life similar to these. The discovery of extremophiles completely changed the way science defines the habitable zone of the universe. Before, it was believed that life could exist only under conditions similar to those on Earth, a narrow band around stars where water remains liquid. Now we know that life can thrive on frozen planets, moons covered by subsurface oceans, or even on asteroids rich in organic compounds. This revelation expanded the horizon of astrobiology and gave new meaning to the search for life on Mars. We are not looking for creatures like us, but for biological systems capable of enduring the impossible. The danger, however, lies in underestimating this resilience. Terrestrial extremophiles are so resistant that they have been found alive after long periods in space. Experiments carried out on the International Space Station have shown that certain bacteria can survive for years exposed to vacuum, ultraviolet radiation, and microgravity. They protect themselves by forming spores, microscopic structures capable of remaining dormant until favorable conditions return. This means that if terrestrial microorganisms can survive space, Martian microorganisms, if they exist, could also survive a trip to Earth. This is the heart of the fear of retrobiological contamination. Something coming from Mars would not need to be large or complex to make an impact. It would only need to be alive enough to adapt. Extremophiles are proof that life is an autonomous force, molding itself to the environment and turning it into home. They live in conditions that challenge our imagination, inside salt crystals beneath ancient ice, or within deep rocks kilometers below the surface. For them, the impossible is only a temporary phase. This adaptability is both beautiful and terrifying. Beautiful because it reveals the grandeur of cosmic biology, terrifying because it reminds us that, in exploring other worlds, we might awaken forms of life we neither understand nor control. On the cold surface of Mars, where temperatures drop below 80 degrees Celsius and solar radiation is intense, there may exist microorganisms that have lain dormant for ages, waiting for gentler conditions. Perhaps they will never awaken, or perhaps they only need a human touch. A probe, a sample, a trace of moisture carried by a terrestrial instrument to restart a cycle interrupted billions of years ago. In such a scenario, humanity's role ceases to be that of observer and becomes that of catalyst. Extremophiles teach us that life does not need permission to exist. It simply happens. And that is why their greatest lesson is not about resistance, but about responsibility. Every planet we touch may be more alive than it appears, and every grain of dust we bring back may carry within it a story that does not belong to us. Among all the safety protocols ever created by humanity, none approaches the rigor and complexity of what is known as Level 4 planetary quarantine. It represents the ultimate threshold of biological caution, the point at which science admits, with humility and fear, that the unknown is too vast to be underestimated. Designed specifically to handle samples brought back from Mars and other potentially habitable worlds, this protocol stands as the most sophisticated shield ever conceived against the risk of retrobiological contamination, the return of alien agents to Earth. It is, in essence, the final barrier between us and the abyss of uncertainty. Level 4. Planetary quarantine has its roots in the era of the Apollo missions. When astronauts returned from the Moon in 1969, there were no guarantees that the satellite was entirely sterile. For that reason, the North American Space Agency isolated both the crew and the lunar samples inside sealed facilities known as the Lunar Receiving Laboratory. For 21 nights, men who had walked on another world were treated as potential carriers of contamination. The risk proved unfounded, but the lesson endured. The universe may hold microscopic secrets beyond even the reach of humanity's most advanced technologies. With Mars, the situation is different. Unlike the Moon, the red planet shows chemical complexity and signs of a past that once harbored liquid water. That makes it a natural candidate for microbial life. For this reason, the return of any Martian sample is classified as an event of absolute biosafety, demanding the highest biological containment standards ever designed. The facility required to receive such samples must combine the engineering of a laboratory that handles lethal pathogens, such as smallpox or Ebola, with filtration and sealing systems capable of withstanding any physical or molecular breach. Imagine a chamber built within another chamber, where pressure is controlled to the millimeter, and air is burned, filtered, and sterilized before leaving. No human being will ever touch the material directly. Every manipulation will be performed by robotic arms within sealed compartments. The air inside the facility will be maintained under negative pressure, meaning that if any failure occurs, airflow will always move inward, never outward. The walls will be lined with steel and non-porous polymer compounds, resistant to chemical corrosion. Every tool used will be isolated, disinfected, and then destroyed. No detail is small when dealing with the unknown. Beyond physical isolation, there is temporal isolation. Anyone who comes into contact with the samples, even indirectly, must undergo long periods of medical observation. The protocols require continuous health monitoring, daily laboratory tests, and personal quarantine. The goal is not only to protect the individual, but also to ensure that no alien microorganism, if it exists, finds a bridge to the terrestrial ecosystem. Scientists often say that Level 4 planetary quarantine is the safest place on Earth, and at the same time the most dangerous. Within its walls will rest what may be the greatest scientific milestone in history, the first intact samples ever brought back from another planet. And along with them, the possibility of something that transcends imagination. The complexity of these protocols also reveals something profound about human nature, the fear of the invisible. For centuries, our greatest threats have come from microscopic beings we could not see. Viruses, bacteria, and parasites have shaped the history of civilizations. Epidemics have wiped out empires and altered the course of humanity. Now, for the first time, that danger may come from beyond the Earth itself. The unknown is no longer hidden in tropical forests or underground laboratories, but in capsules traveling through space. The planetary quarantine protocol is, therefore, more than a technical measure. It is an act of cosmic humility. It symbolizes the awareness that life, wherever it may exist, must be approached with respect and caution. Science, long accustomed to opening doors, here builds an entire system of locks, seals, and barriers, not out of cowardice, but out of wisdom. The facility designed to house the Martian samples, known as the Sample Return Facility, will be built in an isolated location, far from urban centers, surrounded by multiple layers of security. It will be a modern temple of scientific prudence, a fortress of silence where every grain of dust will be studied as if it might contain a universe. Inside it, every microscope will become an observatory, and every test tube an abyss. Level 4 is the threshold where human curiosity meets the frontier of fear. It is a reminder that not every scientific achievement is triumphant. Some are simply solemn. When the samples from Mars finally arrive, we will not merely be studying fragments of another world. We will be confronting the possibility that life in its most primitive and untamed forms is not exclusive to Earth. And in that moment, planetary quarantine ceases to be a technical protocol and becomes a ritual of reverence, because to open a Martian capsule will be, in a sense, to open the universe's own black box. When humankind first set foot on the moon in July of 1969, the world witnessed a moment of glory that redefined history. But behind the triumphant images of Neil Armstrong and Buzz Aldrin, leaving footprints on the lunar soil, there lingered a silent tension, a shadow of doubt that few dared to voice. What if something came back with them? What if, along with the grey rocks and silvery dust, came microorganisms capable of infecting the entire planet? That question haunted the backstage of the Apollo 11 mission and became one of the most curious and least known chapters of the space age, the birth of modern planetary quarantine. At that moment, humanity was about to cross a frontier it had never crossed before, bringing material from another celestial body into the Earth's biosphere. No scientist could state with absolute certainty that the moon was sterile. After all, until then, everything known about it came from remote observations and theoretical assumptions, and science, advanced as it was, still lacked the tools to completely rule out the possibility of microscopic life in extreme environments. The doubt was enough. Prudence demanded action. For that reason, even before the launch of Apollo 11, a complex isolation facility known as the Lunar Receiving Laboratory was built in Houston in the United States. This high-security installation was designed with the rigor of a modern biological containment laboratory. There, lunar samples would be received, opened, and studied inside sealed chambers, while the astronauts remained in isolation for weeks, under constant medical observation. The fear was clear. If any alien microorganism existed, it could escape and spread rapidly, provoking a biological catastrophe. Upon returning to Earth, Armstrong, Aldrin, and Collins were immediately taken into an improvised quarantine capsule aboard the recovery ship USS Hornet. The North American President, Richard Nixon, had to speak with them through a pane of isolation glass. From there, they were transferred to the Lunar Receiving Laboratory, where they remained confined for 21 nights, along with part of the technical team that had come into direct contact with the samples. During that period, daily examinations were performed to detect any signs of infection, immune alterations, or unusual allergic reactions. It was the first time in history that human beings were treated as possible carriers of extraterrestrial life. Meanwhile, the lunar rocks, nearly 22 kilograms collected during the Apollo 11 mission, were subjected to exhaustive testing. Biologists and microbiologists attempted to cultivate them in nutrient media, searching for signs of cellular growth. Samples were exposed to fish, insects, plants, and even small mammals in experiments that today would sound like science fiction. The reasoning was simple and terrifying. If anything happened to these organisms, the entire planet could be at risk. The results, fortunately, were negative. No sign of life was found in the lunar rocks, and the astronauts remained healthy. But the episode left a permanent mark on space policy. It proved that the risk of contamination, however unlikely, could not be ignored. When later Apollo missions brought back new samples, the protocols were maintained and refined, although gradually the fear diminished. By Apollo 15 in 1971, quarantine had already been abolished. but the lesson remained etched on the laboratory walls. The unknown demands respect. What is most fascinating about this episode is the contrast between public euphoria and scientific fear. For the world, Apollo 11's return symbolized humanity's triumph over nature. For scientists, it was an experience in humility, the realization that by touching another world, we were also exposing ourselves to risks we did not understand. That duality still echoes in today's Martian missions. If the Moon, an arid body without an atmosphere, inspired such caution, what can be said of Mars, which once had rivers, lakes, and an active chemistry? The case of the lunar samples also gave rise to a new scientific discipline, experimental astrobiology, dedicated to studying how life might survive beyond Earth and how it might interact with other planetary environments. The isolation of the rocks and the astronauts' behavior in quarantine became models for future planetary protection protocols. It was the first time humanity realized that exploring the cosmos also meant accepting a new kind of responsibility. There were moments of tension during the tests. In one of the early experiments, a sample was accidentally exposed to air for a few seconds, triggering panic among the team. Alarms went off, and the area was evacuated. Even without any sign of contamination, the mere possibility was enough to show how unprepared we were to deal with the unknown. That mix of fear and fascination turned the return of Apollo 11 into a symbolic milestone. It was the day humanity understood that sometimes the greatest danger does not lie in space, but in what we might bring back from it. Today, the lunar samples remain under heavy security, kept in sealed vaults and controlled environments, like relics from a time when humanity was still aware of the magnitude of the mystery it was unveiling. And it is striking to think that if the Moon, silent, airless, and apparently dead, inspired so much fear, the return of Martian samples will demand vigilance 100 times greater. The case of the lunar samples is therefore more than a memory of the space race. It is a warning. It teaches us that science is not only about what we can do, but about what we must avoid. Cosmic exploration is not only conquest, it is coexistence with the unknown. And at the heart of that coexistence lies an ancient whisper, echoing since the first human footprints in the grey dust of the Moon. Space may not be empty, only patient. Throughout the history of space exploration, few goals inspire as much excitement and as much fear as the idea of bringing samples from Mars back to Earth. It would undoubtedly be one of humanity's greatest scientific achievements, the first direct contact with non-sterile material from another planet. The promise is alluring, to analyze Martian rocks, soils, and dust in Earth's laboratories, with all the tools and precision that space cannot offer. Yet behind this advancement lies a silent risk that resides at the boundaries of biology, ethics, and prudence. What if what we bring back is not just stone and dust? What if, among microscopic grains of iron and ice, there exist living, or almost living, structures capable of reacting to Earth's chemistry in ways we cannot predict? Martian samples may carry a complexity that surpasses any previous experience. Unlike the Moon, Mars is a planet with an active geological past, confirmed water ice, and traces of ancient rivers and lakes. These factors make it a natural candidate for the existence of microbial life, even if dormant. And it is precisely this that makes the return of these samples an operation of the highest risk. Even if the fragments appear inert, they could contain complex organic molecules, dormant spores, or chemical structures capable of reacting unpredictably when exposed to oxygen, humidity, and terrestrial enzymes. Scientists call this phenomenon biogeochemical cross-reactivity, when compounds formed in alien environments interact with Earth's environment to generate unknown products. In other words, something that has never existed could come into existence the moment a Martian sample is exposed to Earth's atmosphere. Even without active life, the mere presence of stable organic molecules or chemical catalysts could trigger chain reactions, altering cellular structures or initiating mutations. Biology, when exposed to what was not made for it, may react in unpredictable ways, and nature knows no remorse. The most disturbing issue is that even if these risks are minimal, they can never be reduced to zero. Experiments with terrestrial microorganisms show that life is incredibly adaptable. Bacterial spores can survive for centuries in ice, for millions of years inside salt crystals, and even in rocks exposed to space. Now imagine a Martian form of life, shaped by billions of years of evolution, under intense radiation, low gravity, and a thin atmosphere, coming into contact with Earth's rich, moist chemistry. It would be like awakening a sleeping creature in a new paradise, perhaps harmless, perhaps lethal, but above all, unknown. Some scientists believe that Martian samples may contain alien extremophiles, organisms similar to those that survive under extreme conditions on Earth. Others argue that even without life, Martian compounds could be biologically reactive. This includes substances such as perchlorates, highly oxidizing compounds capable of interfering with biochemical processes and altering organic molecules. Under terrestrial conditions, these substances could react with biological compounds to generate mutations, toxicities, or effects we do not yet understand. And because biology is an interconnected web, a single microscopic fragment interacting with the wrong system could trigger an unpredictable cascade effect. International safety protocols acknowledge these dangers. For that reason, the return of Martian samples will be accompanied by a set of measures that resemble a ritual of containment more than a scientific procedure. The capsules carrying the material will be designed to remain hermetically sealed throughout the journey, and their opening will only occur within maximum-level quarantine facilities, such as those mentioned in the previous section. But the real problem is not in the transport itself. It lies in the very essence of interaction. Once the container is opened, the link between two worlds is completed, and whatever happens next belongs to a realm where human experience has never set foot. The history of science shows that danger often does not arise from the unknown itself, but from the blind confidence in our ability to control it. When early scientists handled uranium in the early 20th century, they could not imagine that curiosity would lead to the creation of the atomic bomb. When biologists began editing genes, they did not foresee that they were opening the doors to global ethical dilemmas. Now, by bringing material from Mars, humanity stands before a new frontier, perhaps the most delicate of all. The risks are not only biological, but also symbolic. By opening a Martian capsule, we will be crossing a barrier that has separated worlds for billions of years. It is the boldest and most arrogant gesture humanity has ever attempted, to bring into direct contact two ecosystems that have never coexisted. Even if Mars is dead, its chemistry remains a system in balance. By breaking that balance and mixing it with ours, we risk introducing variables that even the most advanced science cannot anticipate. Some researchers suggest that before bringing samples back, we should develop orbital laboratories, places of analysis in space where the material could be studied without ever touching Earth's biosphere. Others argue that any return mission should wait until we have a deeper understanding of planetary biology. But human impulse rarely knows patience. The clock of conquest has already started ticking, and the promise of an unprecedented discovery outweighs the fear of irreversible consequences. There is a recurring phrase among astrobiologists: life is stubborn, and ignorance even more so. That sentence captures the essence of the dilemma, because in the end, perhaps the greatest danger does not lie in the rocks that will come from Mars, but in what they represent, the symbol of a humanity that, even aware of the risk, remains willing to challenge its own fate. Bringing Martian fragments home is more than a scientific mission. It is an act of faith in human control over the unpredictable. And perhaps, as so many times before in history, the universe is simply waiting to remind us that curiosity always comes with a price. Since the first telescope was pointed toward the sky, humanity has carried a question that transcends centuries, religions, and civilizations. Are we alone? This doubt, more than a scientific curiosity, is an existential unease. Searching for life beyond Earth is, in essence, searching for ourselves, for a cosmic reflection that confirms the universe is more than silence and emptiness. But hidden within this impulse lies a paradox, a danger that grows in proportion to our curiosity. The act of seeking life may be the very thing that condemns it to extinction. Each probe launched, each sample collected, and each drill that pierces the Martian soil carries without our awareness an invisible seed, the presence of humanity itself. Even the most sterile equipment is never completely free from terrestrial microorganisms. The surface of a spacecraft, a metal joint, a microscopic screw, any of these details may harbor colonies of resilient, silent bacteria. And once those bacteria touch the Martian soil, there is no turning back. They become, immediately, part of that environment. This cross-contamination is the heart of the paradox. In our attempt to discover Martian life, we may be erasing its last chance to exist. Scientists call this forward contamination, and it is one of the greatest ethical dilemmas of modern astrobiology. Since the Viking missions in the mid-1970s, space agencies have developed strict sterilization methods, dry heat chambers, ultraviolet radiation, chemical treatments, and air filtration systems capable of eliminating almost all forms of life. But almost does not mean all. Experiments on Earth show that even bacteria exposed to vacuum and radiation can survive, especially the so-called spore-forming species, which enter a near-eternal state of dormancy. If a single terrestrial cell endures and reaches Mars, it might persist in underground caves, shadowed crevices, or mix with Martian dust. In that instant, the planet becomes hybrid, no longer purely Martian, nor entirely terrestrial. This scenario is not only scientific, but symbolic. It exposes one of the most unsettling truths of the human condition. Our desire to understand is often inseparable from our tendency to destroy. We seek life, but we do not know how to reach it without leaving a mark. It is like stepping into a fragile garden without realizing that, beneath our own feet, bloom the answers we came to find. The paradox deepens when viewed through cosmic time. Mars may have been asleep for billions of years, preserving in its subsurface microorganisms that survived eons of cold and radiation. By drilling into its soil, heating samples, and introducing probes, we may irreversibly disturb a balance that took ages to form. Perhaps those organisms will never awaken again, or perhaps they will, only to find a world changed by our intrusion, unfit to sustain them. Thus, the search for life on Mars might become the final act of its story. The irony is that science itself acknowledges this risk, yet it presses on. There is something inevitable in the human drive to explore. Even aware of the consequences, we move forward, as if knowledge were a form of redemption. It is the same impulse that led ancient explorers to cross oceans, knowing that some would never return. The difference is that this time, the ocean is the cosmos, and what is at stake are not only human lives, but the possibility of other kinds of existence. Some astrobiologists propose that we should treat Mars as a biological sanctuary, a cosmic reserve, where human intervention remains minimal until we fully understand its biology, if it exists at all. Others believe that human presence is inevitable and that contamination has already begun. Neither side is wrong, and that is what makes the dilemma so disturbing. Every choice carries risk. Doing nothing means remaining in ignorance. Acting means risking the destruction of what we seek. The situation becomes even more complex when we remember that Mars may preserve not only present life, but also microscopic fossils of past life. The simple act of digging into a sedimentary layer could alter the chemical signatures that tell the planet's history. If traces of ancient biomolecules exist, we might confuse them with the ones we brought ourselves. The line between discovery and contamination fades away, leaving behind only doubt, eternal, corrosive, insoluble. The search for life beyond Earth is therefore a mirror of our own humanity. We are driven by the desire to know, but also by the desire to control. We want to understand the universe, yet we struggle to leave anything untouched. And perhaps that is the true paradox. While trying to prove that life exists elsewhere, we forget to protect it here. If one day we do find life on Mars, the moment of discovery might coincide with the moment of loss. Because the simple touch of humanity can forever change what we call alien. Life, if it exists out there, is as fragile as the first cell that arose in Earth's primordial oceans, and the human touch, even unintentional, may be the last it will ever receive. Thus, the paradox of cosmic exploration reveals itself in its purest form. The closer we get to the answer, the farther we move from the truth. The search for life may, ironically, be the very act that seals the fate of all life beyond Earth. And in that silence between desire and prudence, perhaps the universe is merely waiting to see if we have learned the difference between discovering and invading. Throughout history, every step humanity has taken toward the unknown has been accompanied by an equally powerful instinct: fear. And it is from that fear that barriers are born. Invisible walls we build not to hinder progress, but to protect what we have yet to understand. Space, with all its vastness, has amplified this ancestral instinct. When humanity began sending ships beyond Earth, it carried not only technology and courage, it also carried the need to draw boundaries. And through those boundaries, we learned the first great lesson of the cosmos. The unknown is not a territory to be conquered, but a presence to be respected. Since the Viking missions in the 1970s, Earth has struggled to establish a set of rules defining what can and cannot be done beyond our planet. These protocols may seem technical, but they carry profound philosophical and ethical weight. The so-called planetary protection, humanity's cosmic code of conduct, was born from the recognition that life is a fragile phenomenon and that even the smallest mistake could forever alter the balance between worlds. These rules are not merely bureaucratic. They are attempts to keep human curiosity from turning into unintended destruction. These barriers are built in several layers. The first is physical. Spacecraft and probes undergo strict sterilization before leaving Earth. Every screw, every component, every fragment of material is subjected to intense heat, ultraviolet radiation, and chemical disinfection. The goal is to eliminate any chance that terrestrial microorganisms might travel clandestinely to other planets. It is a kind of interplanetary hygiene, a way to prevent us from becoming the invisible colonizers of the universe. The second barrier is biological. Samples brought back to Earth, when permitted, pass through extreme containment procedures, such as those of Level 4 planetary quarantine. They are treated as if they might harbor the most lethal pathogens known. This fear does not arise from certainty, but from ignorance. Because the truth is simple and unsettling, we do not truly know what life is. Everything we understand comes from earthly life. Any form beyond that, no matter how small, represents absolute uncertainty. The third barrier is ethical, and perhaps the hardest to maintain. It demands something humanity rarely practices: patience. It means knowing how to wait, to observe before acting, to resist the urge for haste. Modern science, driven by results and achievement, struggles to accept the slowness of the cosmos, but the universe operates on scales that do not bend to human impatience. The lessons learned from Mars, from the Moon, and from our own mistakes on Earth show that every act of exploration demands a moment of reflection. It is in that pause, between desire and action, that true scientific wisdom resides. These barriers, however, are not infallible. They are attempts, symbolic fences that remind us of the vulnerability of our knowledge. With every new mission, new challenges emerge. How can we ensure that a sample will not mutate on its way back? How can we prevent a robot, contaminated by the Martian environment, from carrying particles into Earth's orbit? How can we distinguish between life found and life brought? Each answer gives rise to new questions, and the cycle never ends. But perhaps the most important realization is that these barriers do not only protect Earth, they also safeguard our moral integrity. They remind us that scientific power without ethical limits can become self-destructive. By erecting walls against the unknown, we are trying to protect not only our biosphere, but also our conscience. It is a way of saying to the universe, we know enough to fear what we do not yet understand. At its core, every planetary quarantine, every protection code, and every isolation protocol are expressions of the same sentiment: humility. They are the confession that the universe is greater than our understanding, and that the mere existence of something beyond ourselves demands respect. Science, in its purest form, is made not only of answers, but of reverence. And each time humanity raises a new barrier, what it truly seeks to contain is not the danger outside, but the arrogance within. Earth has learned this lesson painfully many times, through unknown viruses, ecological disasters, and imbalances of our own making. Now, as we look toward Mars, we learn the same lesson on a cosmic scale. Space is not an enemy, but a mirror. It reflects our impatience, our curiosity, and our mistakes, and the barriers we raise, physical or symbolic, are not walls of separation. They are bridges of caution between what we are and what we may yet become. The future of interplanetary exploration will depend on our ability to balance desire with prudence. If we can keep respect above haste, we may one day touch other worlds without destroying them. And if we fail, the barriers we built will be remembered not as the limits of science, but as the final gestures of wisdom before the silence. For centuries, biology was shaped around an apparently absolute principle: every known form of life is based on carbon. This element, abundant, versatile, and stable, is the foundation of everything that lives on Earth. Every cell, every protein, every molecule essential to life arises from the chemical bonds that carbon forms with hydrogen, oxygen, nitrogen, and sulfur. It is the backbone of terrestrial biology, and until recently, it was believed that it should also be the universal foundation of life. But the cosmos rarely bends to human certainties. With the progress of astrobiology, a new hypothesis has emerged, that life may exist in radically different forms, based on elements and processes that challenge everything we know. It is the hypothesis of alien biochemistry, the recognition that life may be more creative than human imagination. This idea began to gain strength through the study of extreme environments on Earth. Researchers discovered microorganisms capable of surviving in chemical conditions so hostile that they defy the logic of traditional biology. Some live in lakes saturated with arsenic, an element that is lethal to almost all known life. Others use sulfur instead of oxygen, or derive energy from reactions involving iron, manganese, and even ammonia. These organisms revealed that life does not depend on a single chemical model. It adapts to whatever is available. This discovery opened the door to a new vision. If life can reinvent itself so many times here, why not elsewhere? The hypothesis of alien biochemistry suggests that forms of life on Mars, or on any other planet, could be based on elements other than carbon, perhaps silicon, which is also capable of forming complex and stable structures. Silicon is abundant on Mars, present in the rocks and in the dust that covers the planet. It forms long, crystalline and resistant chains, and although less flexible than carbon, can create complex compounds under certain conditions. Some theoretical models indicate that silicon-based molecules could function as the skeletons of alien organisms, forming stable structures in environments of low temperature and high radiation, exactly the Martian scenario. Another intriguing possibility is that of life forms based on solvents other than water. On Earth, water is essential to life because it dissolves substances, transports nutrients, and participates in fundamental chemical reactions. But Mars is a world where liquid water is rare and unstable, yet there are compounds such as perchlorates, ammonia, and solid carbon dioxide that could play similar roles under certain pressures and temperatures. In such environments, the chemistry of life would be completely different, perhaps slow, perhaps almost motionless, but still alive. Martian life, if it exists, might not pulse, breathe, or move like ours. It might simply react silently, on timescales that defy human perception. This possibility forces science to expand its definition of life. For a long time, scientists have relied on specific criteria: to be born, to grow, to reproduce, and to die. But these categories become limited when applied to the universe. What about organisms that live for millions of years without reproducing? Or chemical systems that self-organize and evolve without DNA? The line separating the living from the non-living becomes blurred, and perhaps Mars exists exactly on that frontier, a place where chemistry and biology have not yet completely diverged. The danger lies in our own limitation. By searching for extraterrestrial life according to terrestrial parameters, we risk not recognizing it when we find it. Our instruments are calibrated to detect carbon molecules, DNA chains, amino acids, and familiar organic compounds. But what if Martian life uses completely different structures? What if it is invisible to the tools we have built? It is possible that we have already passed it by without noticing, like someone leafing through a book written in a language they have not yet learned to read. Alien biochemistry is not merely a scientific theory, it is a philosophical revolution. It challenges the centrality of terrestrial life and forces us to accept that we may be only one of many possible forms of organized matter. This idea does not diminish the importance of humanity, it expands its horizon. It invites us to see life not as a miraculous exception, but as a natural consequence of the complexity of the cosmos. Yet with that vision comes risk. If there are forms of life based on other chemistries, our contact with them could be devastating. An alien molecule might react violently with terrestrial proteins. A compound inert on Mars could become toxic in Earth's atmosphere. Even the simple act of analyzing such samples could irreversibly alter their chemical balance. What is harmless today could become dangerous simply by existing in a new environment. The hypothesis of alien biochemistry, therefore, is not merely a search for possibilities, it is a warning. It shows that life is far broader, more unpredictable, and more delicate than we imagine. And it reminds us that in seeking to understand the universe, we also become part of it. If there is one thing science must learn from Mars, it is that the cosmos does not fit within human categories. Perhaps the true discovery will not be finding life beyond Earth, but realizing that the very definition of life must change. And when that moment comes, we will understand that the universe was never empty. It was only speaking a language we had not yet learned to hear. When we think of extraterrestrial life, imagination usually takes us to complex beings, creatures with shapes, eyes, and intentions. Yet the true danger does not lie in what we can see, but in what we cannot even imagine. The simplest forms of life are also the most powerful because they operate at the fundamental level of existence, the molecular. A single protein, a microscopic virus, or an alien enzyme could, in theory, interact with terrestrial biology in catastrophic ways. No visible invasion would be necessary, only an invisible reaction capable of altering the destiny of the entire biosphere. The basis of this risk lies in the universal nature of chemical laws. Molecules obey the same principles of bonding, reaction, and energy everywhere in the cosmos. This means that compounds from another planet can indeed interact with Earth's biological systems, but that familiarity is deceptive, precisely because they follow the same chemical laws. These substances might fit into our molecular mechanisms in unpredictable ways. An alien protein, for instance, could bind to human cell receptors, disrupting vital functions. A Martian enzyme could catalyze reactions our bodies neither recognize nor can control. Even a virus without terrestrial origin might parasitize organisms indirectly, altering metabolic processes and triggering mutation chains on a global scale. These scenarios may sound distant, but they already find parallels in phenomena occurring here on Earth. Viruses and bacteria jump from one species to another, transforming into new pathogenic agents. Natural enzymes, when displaced from their original environments, become toxic. Proteins folded incorrectly, known as prions, are capable of destroying human brain tissue through mere molecular contact, without any genetic material at all. If all this can happen within a single planet, imagine what might occur in an encounter between two biospheres that evolved separately for billions of years. The problem extends beyond living organisms to reactive molecules as well. A simple combination of Martian compounds, perchlorates, metallic salts, or unstable substances formed under high radiation could trigger dangerous chemical reactions upon contact with Earth's atmosphere. This could generate toxic gases, free radicals, or catalysts that disrupt local biological processes. Even on a small scale, such interactions could ripple outward like waves across a calm lake, affecting microorganisms, plants, and eventually the entire food chain. Scientists planning the return of Martian samples take this risk into account at every stage. For that reason, the handling of material will occur under maximum containment, constant monitoring, and robotic manipulation within sealed artificial atmospheres. The goal is to prevent any contact between Martian molecules and terrestrial organisms. Yet the nature of life, or living chemistry, is cunning. A reaction does not need to be large to be dangerous. A microscopic particle, an invisible fragment of protein, might survive filters, pressure, and sterilization, and a single human error would be enough to break that barrier. There is also a subtler and at the same time more disturbing aspect: biochemical incompatibility. On Earth, all life is built from molecules that share a property called chirality, a kind of chemical handedness. Our proteins and amino acids exist only in one specific orientation, as if every piece of life's puzzle followed the same pattern. But there is no reason to assume this is universal. If Martian life exists, its molecules may be the mirror image of ours, the inverted reflection. That would mean that upon contact, our enzymes would not recognize their counterparts. Worse, they might react chaotically, like puzzle pieces that fit the wrong way and destroy the structure instead of completing it. This hypothesis is more than theoretical. Laboratory experiments have already shown that molecules with opposite chirality can interfere with vital processes, blocking enzymes and paralyzing cells. This is the true terror of cosmic biology, the invisible, silent, and uncontrollable danger. No microscope could predict how such substances would behave in a living environment. Modern science, however advanced, still cannot fully simulate the behavior of hybrid biological systems, those formed by the interaction of molecules from different planetary origins. Any attempt to predict all risks would be an act of arrogance. The universe is more creative than human calculations, and yet the temptation to bring back samples is irresistible. The promise of deciphering the secret of Martian life is too strong to be restrained by fear. In cutting-edge laboratories, scientists already discuss protocols to analyze unknown compounds, study the stability of alien molecules, and observe possible cross-reactions with terrestrial samples. What few admit openly is that deep down, there are no guarantees. It is a leap of scientific faith, the same kind of faith that once led explorers to cross oceans and scientists to split the atom. The question, therefore, is not whether we should be afraid, but whether we are ready for the kind of responsibility that fear demands. The molecular danger is, above all, a reminder. Life, in any form, is unpredictable. What we call the biosphere is a fragile balance, and a single foreign touch, one wrong molecule, can disrupt its harmony. When humans touch another planet, they do not bring only instruments and machines. They carry the essence of curiosity itself. And that curiosity, paradoxically, may become the vector of a biological event without precedent. Perhaps when the first Martian samples are finally opened, the greatest risk will not lie in what they contain, but in the confidence with which we believe we can control them. The universe, after all, has shown countless times that life, at any scale, is the most dangerous and untamable force that exists. Among all the theories about the origin of life, few are as fascinating and as unsettling as panspermia. The idea, born in the 19th century, suggests that life did not originate exclusively on Earth, but was seeded from space. Microorganisms or organic compounds may have traveled between planets, embedded in fragments of rock ejected by cosmic impacts, surviving radiation and vacuum for millions of years until finding a new home where they could flourish. But there is a variation of this hypothesis that completely inverts the perspective, reverse panspermia, which proposes that life, instead of coming here, may now be preparing to go back there. And this return, if it occurs, could close a biological cycle with unpredictable consequences for both Earth and Mars. This theory is not merely poetic speculation. It is supported by geological and experimental evidence. We know that fragments of Mars have already fallen to Earth, brought here by ancient collisions. It is estimated that more than 200 meteorites of Martian origin have been found on our planet, many with mineral structures compatible with Martian soil. Inside them, some fragments contain microcavities that could have sheltered complex organic molecules. One of the most famous examples is the meteorite ALH 84001, discovered in Antarctica in 1984. It contains structures that, according to some scientists, resemble microscopic fossils, possible traces of ancient Martian life. Although the debate remains unresolved, the fact that a piece of Mars traveled here proves that the exchange of material between planets is not only possible, but recurrent. Now imagine the reverse, samples from Earth being carried to Mars. Since the beginning of the space age, thousands of tons of human equipment have been sent into space. Satellites, probes, modules, and even orbital debris traverse the solar system, and many inevitably carry traces of terrestrial life. Microorganisms encapsulated in dust, spores resistant to vacuum, fossilized DNA fragments. All of these could, in theory, survive an interplanetary journey. In other words, reverse panspermia has already begun, silently, without our awareness. But what makes this hypothesis dangerous is that if terrestrial life truly originated on Mars, this return could reactivate a long-dormant biological link. If our microbial ancestors came from Mars, then there exists a genetic relationship, however distant, between the biology of both worlds. The reunion of these two lineages, separated by billions of years of independent evolution, could trigger unpredictable reactions. As if two ancient species from the same system met again after ages of isolation, they might recognize each other, or annihilate one another. The idea that life can circulate throughout the cosmos is not only scientific, it is deeply symbolic. If life on Earth began on Mars, then we are, in a sense, Martians, fragments of a cosmic cycle that began even before Earth took its present form. And now, ironically, we attempt to return to the planet that may have been our cradle. The danger lies in failing to understand what such a return means. When a species meets its origin again, the impact can be devastating. The chemical differences accumulated over eons could generate fatal incompatibilities. A protein, a virus, an ancestral enzyme, everything that once gave rise to us could now be the very thing that destroys us. The theory of reverse panspermia also raises a disturbing ethical question. If we were seeded by Mars, what right do we have to seed it again? Would we merely be closing the natural cycle of cosmic life, or desecrating the very soil from which we came? This doubt divides scientists and philosophers alike. For some, the spread of life is inevitable, a natural continuation of evolution. For others, it is an act of cosmic invasion, a contaminated return. From a biological perspective, the danger is real. If terrestrial life is compatible with Martian life, the two could compete for the same chemical space. The life of one planet could extinguish that of the other. If they are incompatible, the reactions between their biochemistries could generate toxic substances, mutations, or molecular collapses. Either hypothesis could place Earth and Mars in a cycle of continuous retrocontamination, an exchange of living molecules moving back and forth, altering ecosystems before they even exist. This possibility transforms the concept of contamination into something deeper. It would not be just a technical accident, but a natural phenomenon of reconnection between living worlds. The cosmos would cease to be an empty space and become a vast, expanding ecosystem where life itself is the element that binds everything together. Yet for Earth, this connection could be dangerous. The return of Martian organisms, even inert ones, could reactivate ancient genetic processes, awakening mechanisms that our biology has long forgotten. What is alien to us might, for life itself, be only memory. The theory of reverse panspermia forces humanity to face the universe not as a field of exploration, but as a living system in delicate balance. Every sample brought, every probe sent, every fragment returned is a biological exchange, and ultimately an exchange of destiny. Life in its essence is always seeking to return. Perhaps what we call space exploration is in truth merely life trying to find itself again. And if that is true, the most important question is not whether we are alone in the universe, but whether we are ready to meet what created us. To understand how life could exist on Mars, scientists decided to do the unthinkable: recreate the red planet right here on Earth. In sealed laboratories, far from natural light, artificial atmospheres are produced, composed of rarefied carbon dioxide, iron-rich dust, and freezing temperatures. The goal is to test an ancient and fascinating hypothesis. If life can survive Earth's extreme environments, in arid deserts, frozen poles, and volcanic depths, perhaps it can also withstand the hardships of Mars. Thus was born a new branch of experimental astrobiology, the simulation of Martian ecosystems. These experiments are far from simple. To begin with, it is necessary to recreate what is known as Martian regolith, a complex mixture of dust, pulverized rock, salts, and highly oxidizing compounds such as perchlorates. These salts, abundant on Mars, are toxic to most forms of terrestrial life, but may also serve as a chemical energy source for extremophiles. In planetary simulation chambers, this soil is placed under an atmospheric pressure similar to that of Mars, about 1/100th of Earth's, and subjected to average temperatures ranging between 70 and 80 degrees Celsius below zero. Ultraviolet radiation is reproduced with high-intensity lamps, simulating the constant bombardment of solar particles that the planet receives due to the absence of a protective magnetic field. In this hostile scenario, scientists place bacteria, algae, and extremophile fungi collected from Earth and wait. The results are astonishing. In several cases, microorganisms survived. Some bacteria endured for months, entering a dormant state and reactivating when conditions improved. Bacterial spores were able to maintain their structures intact, even after exposure to intense radiation and partial vacuum. Certain fungi collected in Arctic caves showed slow growth capability in simulated Martian soil, taking advantage of traces of moisture and mineral nutrients. These findings reveal that the boundary between living and unviable is far thinner than we once believed. But the most remarkable experiment is not about resistance, it is about adaptation. Researchers observed that, in some cases, the organisms not only survived, but also altered their cellular structure to suit the new environment. Enzymes were modified, cell membranes became thicker, and protective pigments intensified to absorb ultraviolet radiation. It was as if life itself understood that it was being tested and responded to the challenge. This biological plasticity is what makes the hypothesis of Martian life plausible. If life can adapt so quickly here, it could very well have found ways to remain active, serious, or dormant there. Beyond testing known microorganisms, some scientists decided to go further. They created theoretical models of Martian organisms. These simulations use supercomputers and synthetic biology programs to design hypothetical beings that could exist on Mars based on alternative biochemistries. A famous example is the model of the perchlorophiles, organisms that would use perchlorates as an energy source, converting them into oxygen and heat, a strategy that would allow them to survive underground where the temperature is more stable. Other models suggest the existence of microalgae that could use iron instead of magnesium in photosynthesis, taking advantage of the dim sunlight filtered through Martian dust. Although still hypothetical, these theoretical experiments help expand our scientific imagination and prepare detection protocols for life forms that may not resemble anything on Earth. The laboratory, therefore, becomes a mirror of the cosmos. Inside it, scientists play with the very concept of creation, testing the limits of biology and chemistry. But this curiosity also carries a moral dilemma. By creating life forms adapted to Mars, humanity comes dangerously close to the line between study and colonization. Because in essence, these experiments are fabricating organisms capable of living on another planet. What would happen if one day they were actually taken there? Would we be studying Martian life or inventing it? Another delicate point is that of reverse contamination. If these artificial organisms, created to withstand Martian conditions, were to return to Earth, they could carry mutations that make them unpredictable. Even if harmless, their modified biochemistry could interact with terrestrial biology in unexpected ways. This has led many researchers to propose ethical rules for experimental astrobiology, arguing that no life form modified to survive beyond Earth should ever be created outside absolute containment environments. The study of hypothetical organisms in Martian conditions reveals how humanity is both creator and destroyer. In our desire to understand life, we end up recreating it, and in doing so, we step into a realm we were never meant to possess. It is a cosmic irony. The more we try to understand what alien life means, the more alien we become to our own creation. These experiments reveal a profound lesson. Life is the greatest engineer in the universe, and humanity, in trying to imitate it, walks on sacred ground. Every bacterium that survives a Martian simulation is a reminder that the cosmos does not need permission to be fertile, and perhaps in the end, these sterile chambers conceal more than science. They hide a premonition of a future in which humans will cease to be mere observers of the universe and will become one of its biological agents. When that happens, the question will no longer be, is there life on Mars, but which one came first and which one will survive? Few frontiers in human history are as dangerous as the one that separates discovery from creation. For centuries, humankind has devoted itself to understanding life, its origins, its forms, its invisible laws. But in recent decades, that quest has crossed the boundary of observation and entered the realm of fabrication. Synthetic biology, joined with genetic engineering, has given humanity the power to create artificial organisms, living structures that have never existed in nature. And it is precisely at this point, where curiosity touches creation, that the most unsettling dilemma of modern science emerges. How far can we go to understand what we do not yet know without becoming the very danger we seek to avoid? In the Martian context, this question becomes even more urgent. Astrobiology is not only the science of searching for life, but also of imagining it. And in the act of imagining, we inevitably begin to create. Many laboratories today are developing synthetic organisms with traits inspired by Martian conditions. Bacteria resistant to ultraviolet radiation, fungi capable of surviving without oxygen, algae designed to perform photosynthesis in thin atmospheres of carbon dioxide. The official goal is to understand how life could evolve on another world. But on a deeper level, these experiments mean something far more disturbing. We are creating the first inhabitants of a planet we have not yet set foot on. This advance raises ethical questions comparable to those surrounding cloning and genetic manipulation. By fabricating life, science ceases to be an observer of nature and becomes a creative force, an entity that can literally decide what exists and what should not. The problem is not only technical, but philosophical. If we create an organism capable of surviving on Mars, is it terrestrial or Martian? Does it belong to Earth, which conceived it, or to Mars, which inspired it? And even more profoundly, who has the right to decide the fate of a form of life that was not born from a natural process? These questions go far beyond academic debate. They touch the core of scientific responsibility. Creating life to study life is, in itself, a paradox, because in doing so, we risk replacing the mystery we seek to understand with an imitation of our own making. Synthetic Martian biology may teach us much about the limits of existence, but it may also blur the boundary between what is discovered and what is manufactured. Artificial creation can contaminate the object of study, making it impossible to distinguish what is truly alien from what is the product of human design. There is also a subtler moral danger. The creation of organisms resistant to the Martian environment is not merely a scientific exercise, it is a form of power. The same knowledge that can be used to study harmless microbes can also be used to manufacture destructive biological agents, adapted to extreme conditions. In other words, by learning to create alien life, humanity also learns to create new forms of death. And that duality has accompanied the entire history of science. The fire that warms also burns. The energy that illuminates also destroys. Some scientists argue that the creation of experimental organisms is inevitable and even necessary to prepare for future missions to Mars. Others contend that there is an ethical line that should never be crossed, the line between observing nature and imitating it. Observation requires humility. Imitation requires control. And when science chooses control, it becomes what it has always feared, a mirror of its own arrogance. The dilemma of creation becomes even more serious when we remember that synthetic organisms do not obey the same rules as natural biology. They can evolve in unpredictable ways, recombine genes, absorb mutations, and become something completely different from what was designed. Even in isolated environments, genetically modified microorganisms have been observed developing unexpected traits after only a few reproductive cycles. Now imagine something similar on an interplanetary scale, a being engineered to survive on Mars, but altered by radiation, dust, and unknown minerals. What returns to Earth might no longer be what was sent. Behind all this risk lies an uncomfortable truth. Scientific creation is also an act of faith. No laboratory, however advanced, can predict every outcome of the life it creates. At that point, science approaches dangerously close to what it once criticized, the belief in absolute power over nature. And that is precisely where the danger is born. Because the universe is not a controlled experiment, and life, wherever it exists, does not obey human logic. The ethics of creation demand a kind of wisdom that goes beyond technique. It demands consciousness. To create something is to perform an irreversible act, and every new being, even a microscopic one, is a presence that cannot be undone. Perhaps the true challenge of modern science is not to discover life on Mars, but to resist the temptation to fabricate it. Because when humankind becomes the creator of worlds, the cosmos ceases to be a mystery and becomes merely a mirror of its intentions. And perhaps amid the Martian silence, life, whether natural or artificial, is simply waiting to teach us that knowledge without limit is the same as destruction without intent. Since humanity raised its first telescopes, Mars has been seen not only as a distant planet, but as a promise, a red sphere that feels at once familiar and unreachable, cold yet full of potential life. The idea of a terraforming Mars ice, that is, making it habitable for humans, is one of the boldest scientific ambitions ever conceived, and for many, it is also the inevitable destiny of our species. The dream is simple to picture: melt the polar ice, release gases into the atmosphere, warm the planet, and transform it into a new home. But behind that vision lies a devastating dilemma. Every step toward colonization is also a step toward the destruction of what Mars already is. Terraforming is built upon a dangerous premise, that Earth is the perfect model for life, and that everything different must be corrected. It is the same logic that shaped empires, destroyed ecosystems, and wiped out entire species. Now it expands beyond the terrestrial atmosphere, carrying the same vices of the civilization it seeks to escape. When we talk about warming Mars, releasing greenhouse gases or introducing bacteria and plants to produce oxygen, we are essentially speaking of a form of biological colonization. And like all colonization, it carries the risk of erasing the other, even if that other is just an alien microbe. If life exists on Mars, it is probably microscopic, perhaps underground, hidden within layers of ice and salt. It may have evolved independently, following paths entirely different from terrestrial biology. By terraforming the planet, we would radically alter those conditions. The heat that melts the ice could also kill organisms adapted to the cold. The oxygen released might be toxic to beings accustomed to thin air and carbon dioxide. Water, the universal symbol of life, could be poisonous to microorganisms whose cellular structures were shaped by dryness and the absence of oxygen. In our eagerness to create life, we might exterminate one that has existed quietly, discreetly, and perfectly adapted to its world. This ethical paradox is known as the dilemma of planetary bioethics. It questions whether humankind has the right to modify other worlds in the name of survival. Colonizing Mars might ensure the continuity of the human species, but at what cost? Would we be saving humanity or destroying an entire chapter of cosmic history? Each Martian molecule carries the chemical record of billions of years of planetary evolution. To interfere with that balance is to erase the pages of a book before we have finished reading it. Beyond the biological issues, there are geological ones. Terraforming would require colossal manipulations, nuclear explosions to release carbon dioxide, vast factories producing greenhouse gases, networks of orbital mirrors to concentrate sunlight. Each of these actions could bring unpredictable consequences. The atmosphere could become unstable, the soil toxic, the radiation even more intense. Mars could end up as a semi-habitable planet, neither dead nor alive, but chemically mutilated. The dream of a new home would become a simulacrum, a desert redesigned to appear fertile, yet devoid of the natural balance that makes a world truly alive. The danger, however, goes beyond science. It is psychological and symbolic. To terraform Mars is, in essence, to repeat the history of Earth. It is to bring to another world the same mistakes that exhausted our own: haste, exploitation, and the belief that humankind is the center of the universe. By transforming Mars, we would not only be changing a planet, we would be exporting our arrogance. The same mentality that destroyed entire ecosystems on Earth now disguises itself as interplanetary hope. Humanity, instead of learning from its mistakes, tries to bury them in another soil. Terraforming, therefore, is not just an engineering project. It is a philosophical mirror. It reveals how deeply humanity has yet to learn to coexist with what is different. We want to make Mars into a new Earth, but perhaps the true challenge is to learn to respect it as Mars. A world does not need to be habitable to be valuable. The beauty of the cosmos lies precisely in the diversity of its equilibriums. To destroy an alien environment in order to adapt it to our biology is an act of arrogance, not evolution. Some scientists propose an alternative: reversible terraforming, a process that would allow humanity to explore Mars without permanently altering its natural balance. It would be a form of temporary coexistence, a human presence that learns from the planet instead of dominating it. But this idea remains theoretical, and perhaps human time is too short to wait. While ethics and caution are debated, rockets are already being launched, missions are planned, and Martian soil prepares to receive visitors. If terrestrial life one day establishes itself on Mars, it will be a historic milestone. But it may also be the epitaph of a world that never had the chance to fully bloom. The first human step on Martian soil may, at the same time, be the last breath of the biology that inhabited it for ages. In the end, the greatest danger of terraforming is not the destruction of a planet, but the proof that humankind has never truly changed. Still a conqueror, even when gazing at the stars. And if there is a lesson to be learned from Mars, it is this: The universe does not need to be shaped in our image. We are the ones who must learn to fit within it. To understand the environmental impact of terraforming Mars, one must first recognize that every planet is a system in balance, even when that balance is hostile to terrestrial life. Mars, in its current form, is stable within its own chemical logic, cold, arid, with a thin atmosphere composed almost entirely of carbon dioxide. Its winds, dust storms, and seasonal cycles follow precise internal laws. Altering any of these variables means altering the entire system. The idea of turning Mars into a new Earth may sound inspiring in speeches, but in practice it is a recipe for the collapse of an entire world, a chemical, physical, and possibly biological collapse. The first impact would come from the attempt to thicken the Martian atmosphere. To warm the planet, it would be necessary to release vast amounts of greenhouse gases, carbon dioxide, methane, or ammonia, capable of trapping solar heat. Theoretically, this could be achieved by detonating the polar carbon dioxide ice or installing factories to release these gases artificially. But Mars does not have enough gravity to retain a dense atmosphere for long periods. Most of the released gases would eventually escape into space, requiring constant and eternal replenishment. In other words, terraforming would create an artificial dependency, a planet that would only remain habitable as long as human machines kept working. If they stopped, the climate would revert to lethal conditions within a few years. The second impact would be chemical. The Martian soil is rich in salts, metals, and reactive substances such as perchlorates, which rapidly oxidize organic molecules. Introducing liquid water and oxygen into this environment would trigger an explosion of unpredictable reactions. Stable compounds would break down, minerals would be transformed, and new toxic gases could emerge. Even small amounts of moisture could release chlorine and other corrosive substances into the atmosphere, destroying any attempt at chemical stability. In an extreme scenario, Mars could become a chemically unstable planet with corroded surfaces and toxic air, a desert even more lethal than it is today. The third impact would be biological. The introduction of terrestrial microorganisms, no matter how carefully controlled, would completely alter the planet's ecological composition. These organisms could dominate the environment rapidly, consuming the limited resources and eliminating any possible native species, if they still exist. The same process that on Earth we call biological invasion would repeat itself on a planetary scale. Terrestrial life would spread like an epidemic, adapting to the new soil, modifying minerals, and perhaps generating unknown chemical byproducts. What was once a pure desert shaped by Martian nature would become a hybrid, a chemical and biological colony of Earth. But the impacts would not stop at the soil. The attempt to warm Mars, would also alter its atmospheric and geological cycles. The rise in temperature could release gases trapped beneath the surface, triggering violent storms and turning Martian dust into a permanent curtain that blocks sunlight. The reduction in ultraviolet radiation could paradoxically favor the growth of terrestrial organisms, accelerating biological imbalance. In a short time, the planet would become unrecognizable, neither Mars nor Earth, but something in between, an artificial environment sustained by the error of ambition. Supporters of terraforming argue that such changes are necessary and that Mars's natural state does not need to be preserved because it is sterile. But this is an anthropocentric and limited view. Even an apparently lifeless planet possesses scientific and philosophical value. The rocks, minerals, and dust of Mars tell a story of billions of years of cosmic evolution. Each layer of soil is a record of the formation of the solar system, a unique geological memory. To alter that is like erasing the fossils of Earth's origin in exchange for a short-lived environmental experiment. Moreover, the chemical collapse caused by terraforming would not be confined to the planet itself. The released dust and gases could affect Mars's orbital balance, alter its surface temperatures, and even interfere with future space missions. The presence of volatile compounds and toxic aerosols would create permanent risks for astronauts and robots. And if by any failure these materials were brought back to Earth, in capsules, equipment, or samples, they could carry new chemical combinations, unpredictable and potentially dangerous. There is, therefore, a bitter irony in terraforming. It promises to create life but may only spread death. The process of turning Mars into a habitable world would, in practice, mean extinguishing what it already is. It would be the annihilation of the different in the name of the familiar. Humanity, in trying to reproduce its planet elsewhere, would prove that it has not yet learned to live in harmony, even with its own home. Some philosophers of science call this phenomenon biological imperialism, the human tendency to impose its form of life on every environment, even when it does not understand the consequences. This mindset turns terraforming into an act of cosmic arrogance, the desire to make the universe a reflection of Earth. But the cosmos does not need copies. It needs humble observers, willing to learn from its differences. The chemical collapse of Mars, should terraforming continue, would be a tragic milestone, the first alien ecosystem destroyed before it was ever discovered. The price of the dream of living on another planet would be the death of the planet itself. And in the end, humanity would realize that the problem was never the lack of habitable worlds, but the inability to inhabit its own without destroying it. Since the beginning of the space age, humanity has nurtured a dream to expand beyond Earth, to build cities under other skies, to breathe in manufactured atmospheres, and to walk on soils that have never known human footsteps. This ideal, noble in appearance, is often presented as the salvation of our species. If we destroy Earth, some say, we'll have Mars. But what few admit is that by bringing terrestrial life to another planet, we would not merely be inhabiting a new world, we would be contaminating it. And perhaps in essence, that contamination is inevitable, because wherever humankind goes, it carries its biology, its history, and its mistakes. To colonize, therefore, is a double act: creation and destruction. When a human steps onto another planet, the simple contact with the ground alters its composition. Invisible microorganisms escape from the skin, the clothing, the breath. Every human cell is a moving colony, hosting trillions of symbiotic bacteria. By breathing, speaking, or sweating, the explorer is already seeding the environment with traces of the terrestrial biosphere. It does not matter how many barriers are raised or how strict the sterilization protocols may be. Life is persistent, and it always finds a crack. The first human step on Mars will also be the first act of interplanetary contamination. This phenomenon is inevitable because the very definition of life implies expansion. Life knows no borders. It spreads, adapts, and occupies. When we carry life to another planet, even unintentionally, we trigger a chain of unpredictable transformations. Terrestrial microorganisms can settle in rock fissures, react with Martian compounds, and generate new molecules. Over time, these small interactions may modify the chemical environment, alter rock color, gas balance, and even the planet's reflectivity. The once untouched world begins to bear the human signature, not in monuments, but in invisible colonies. Contamination, in this sense, is also symbolic. To colonize is to project humanity onto the unknown. We turn planets into laboratories, deserts into experiments, and horizons into property. The history of Earth proves it. Every act of colonization began with curiosity and ended with destruction. Peoples, cultures, and ecosystems were wiped out in the name of progress. Now the same instinct turns toward the cosmos. Space becomes the new frontier, and Mars the new colony. But the paradox is cruel. To make Mars habitable, we must first make it uninhabitable for any form of life it might already possess. Even if Mars is sterile, its integrity still holds value. It is the only intact record of how a planet can evolve without the interference of life. Altering it would mean erasing part of the universe's history. And if there is any form of life there, even microbial, even dormant, our arrival would be the biological equivalent of a mass extinction. A terrestrial organism, no matter how small, can destroy entire ecosystems, as we have seen countless times on our own planet. Invasive species have turned islands into deserts and forests into dead fields. On Mars, the effect would be even more devastating because the environment would have no natural defenses. Contamination, however, is not only biological, it is also cultural and philosophical. By colonizing another world, we impose upon it our way of thinking, our symbols, our language. We call its regions hemispheres, give earthly names to its mountains and seas, and project our geography onto a planet that never needed it. Thus, even emptiness becomes an extension of the human ego. The dream of colonization, seen under this light, reveals itself less as an expansion of life and more as the repetition of the same ancestral mistake, believing that everything that exists was made to be inhabited, used, and transformed. Some argue that colonizing is the next natural step in evolution, that the human being is the messenger of life, spreading it across the cosmos. But that argument ignores a simple truth. Life does not need messengers. It already knows how to spread on its own. The proof lies in bacteria that survive in space, spores that sleep for millions of years, and meteorites that travel between planets carrying organic compounds. Life did not choose us as its carriers. We simply assumed that role for ourselves. The act of colonizing Mars, therefore, is not a scientific conquest, but an ethical test. It will place humanity before a choice: to respect the otherness of another world, or to mold it in its own image. And that choice will reveal more about who we are than any discovery we might make there. If we choose respect, perhaps we will learn to coexist with the cosmos. If we choose imposition, we will repeat on Mars the same cycle of destruction we have lived on Earth, only in another setting, under another sky. To colonize is to contaminate, because to live is to transform. But there is a difference between transformation and domination. The first is a natural dance between being and environment. The second is an attempt to impose order where there is mystery. When humankind tries to domesticate the universe, it forgets that it is also part of it. The danger of interplanetary colonization does not lie in the bacteria we carry, but in the mentality we bring. The belief that the cosmos is an extension of our domain. And perhaps the greatest paradox of all is this: in seeking new worlds to live in, humanity risks discovering that the true enemy of life was never space, but itself. Ever since the first images of Mars reached Earth, a fantasy began to spread among engineers, entrepreneurs, and visionaries that the red planet could be cleaned of dust, of cold, of the absence of oxygen, cleaned of everything that makes it hostile to human life. This idea, disguised as progress, carries a deep and dangerous symbolism, because behind it lies the old belief that humankind can purify the universe, that it can fix what nature supposedly did wrong. But the truth is that the idea of cleaning Mars is merely a magnified reflection of the same impulse that led to the destruction of Earth. In the language of space colonization, cleaning means preparing, removing toxic elements, leveling terrain, modifying the air, warming the climate. It sounds technical, but at its core it is philosophical. It begins with the assumption that the natural world must adapt to humanity, not the other way around. This mindset is ancient. It shaped empires, felled forests, drained wetlands, and extinguished species. Now the same logic extends into the cosmos. When we speak of cleaning Mars, what we truly mean is turning Mars into a reflection of Earth, and of the Earth we have made, not the one we inherited. The problem is that nature does not need purification, it is balance. Every element of Mars, its iron-rich dust, its thin atmosphere, its soil filled with perchlorates, forms a coherent chemical system, even if hostile to human life. To alter it in the name of habitability is to commit environmental violence on a planetary scale. The red iron that covers the soil is not dirt, it is identity. The dust is not imperfection, it is part of its geological story. Cleaning Mars would be like erasing its memory, sweeping away billions of years of cosmic evolution under the illusion that we are improving something. This arrogance already has precedence. On Earth, humanity also believed it could purify the world. It tried to clean rivers and ended up poisoning them with chemicals. It tried to correct forests and destroyed entire ecosystems. It tried to stabilize the climate and caused global warming. The concept of purification, when driven by ignorance, always ends in destruction. It is the cycle of human arrogance, believing we understand natural balance better than nature itself. Mars is now the new stage of that illusion, a planet that does not need to be cleaned but understood. Some defenders of terraforming argue that cleaning Mars is an act of hope, the chance to give humanity a fresh start, a world without pollution, wars, or borders. But that vision is a mirage. The problem does not lie in the places we inhabit, but in the way we inhabit them. If humankind destroyed Earth, it was not because of lack of space, but because of excess ambition. Carrying that ambition to another planet would only transfer ruin to a new cosmic address. And when that happens, Martian dust will cease to be a symbol of mystery and become a symbol of repetition. There is yet a deeper symbolic aspect. Humanity projects onto Mars the desire to cleanse itself. For many, colonizing another planet is a form of redemption, an attempt to escape from the mistakes committed here. But that escape is an illusion. There is no purification without repentance and no redemption without change. If humankind carries the same mindset that destroyed forests, seas, and atmospheres, it will also carry its own spiritual contamination. Mars will not be a new beginning, but a continuation, the same story, under a different sky. Cleaning Mars also reveals an ancient fear, the fear of chaos, of the uncontrollable, of what is different. We want a cosmos that resembles us, ordered, predictable, domesticated, but the universe is not a garden. It is an organism in constant transformation. To purify it is to deny its essence. True progress does not lie in shaping the universe in our image, but in learning to live within its complexity. That is why the idea of cleaning Mars is, at its core, a metaphor. It shows that humankind has not yet understood what it truly means to live in harmony with the unknown. It is not about purification, but about acceptance. Acceptance that Mars is what it is, cold, dry, harsh, and beautiful, that the dust covering it is its skin, and the silence of its atmosphere is its voice. To destroy that in the name of habitability would be like silencing a form of life we have not yet learned to hear. Earth does not need a replacement, and the cosmos does not need to be improved. What needs cleansing is not Mars, it is human consciousness itself. As long as we seek to clean the universe without first cleaning our own mistakes, every new planet will be just another stained page in the same book. And perhaps when we look upon Mars covered by human colonies and altered skies, we will realize too late that what we called purification was always just another name for destruction. Mars has always been more than an astronomical destination. It is a mirror, a distant reflection of what humanity is and what it believes itself to be. When we look at the red planet, we are not merely observing a frozen desert. We are gazing into the symbolic image of our own ambition, our desire for control, and our refusal to accept limits. Mars is the cosmic portrait of human arrogance, a silent reminder that humankind is never content with understanding. It must possess. The planet's red color has always carried a deep emotional weight. To the ancients, Mars was the god of war, a symbol of conquest, strength, and destruction. And ironically, it is that same spirit that now drives the modern space race. We speak of conquering Mars, taming it, claiming it. The language of exploration mirrors that of ancient warfare. And perhaps without realizing it, we are turning the cosmos into the ultimate battlefield. Not a war between nations, but between humankind and nature itself. Every rocket launched is a declaration of power, and every planned colony, a flag planted in the unknown. Yet the red mirror reflects more than ambition. It also reveals our fragility. The desire to go to Mars is born in part from fear, the fear of extinction. Humanity knows it has damaged its own home and now seeks another before it is too late. Mars has become the symbol of repentance disguised as hope. We want to flee the planet we have suffocated and find another where we can breathe again. But the paradox is cruel. We carry with us the same breath that pollutes, the same gesture that exhausts, the same gaze that turns everything into a resource. What condemns us is not the planet we inhabit, but the way we inhabit it. Human arrogance manifests itself in something subtler, the belief that everything in the universe can be measured and explained. When we look at Mars, we seek to quantify, to compare, to categorize. We analyze every rock, every molecule of gas, every grain of dust, and yet in doing so we lose the essentials, the mystery. The red planet, in its silent vastness, does not need to be explained, it needs to be respected. Science, for all its power, is still a small language before the immensity of the cosmos, and if we forget that, our search for knowledge will become a tool of domination. In Mars we see the portrait of Earth before us, and perhaps after us. The dry soil, the eroded mountains, the thin air, all of it is a warning. This is how worlds die. Every crater is a cosmic scar, a reminder that even planets are fragile. Yet instead of reading this warning as a lesson, humanity sees it as an opportunity. We want to transform the planet that symbolizes death into the stage for new life. And in doing so, we repeat the same old mistake. We confuse power with redemption. The red mirror also reveals the distance between what we are and what we believe ourselves to be. We speak of colonizing Mars as if we were gods, yet our civilization still stumbles over the most basic conflicts: hunger, inequality, wars, environmental collapse. We search for new worlds while destroying our own. It is as if humanity were trying to erase the reflection in the mirror instead of facing what it shows. Every space mission, every promise of colonization, is an escape from responsibility. Mars is the altar upon which we lay our sins, hoping that the void will grant us absolution. Yet this mirror does not lie. It reflects exactly what it sees: a species both fascinating and destructive, capable of creating beauty and ruin in equal measure. When we look at Mars, we see the cosmic version of Earth, not as it is, but as it may become. A world that once had rivers and atmosphere, now reduced to dust and silence. Mars is the future of Earth if we fail to change. There is a bitter beauty in that, because if we learn to look with honesty, the red mirror may teach us something no technology ever could: the need for humility before the universe. We are not conquerors. We are temporary visitors in a cosmos that existed long before us and will continue long after. True wisdom lies not in transforming Mars, but in understanding what it is trying to tell us. When the first human finally steps onto that red soil, perhaps the most important moment will not be one of conquest, but of silence. The moment when, for the first time, we realize that there is nothing to conquer, only something to respect. The red mirror does not wish to be cleaned or shaped. It wishes to be understood. And if we can see ourselves within it, perhaps there is still time to save the reflection we are leaving behind here, on Earth. The greatest danger of Mars was never its toxic dust, its frozen winds, or its deadly radiation. The true danger is invisible, and it travels with us. It dwells within the human heart, in the mind that turns the unknown into domination and mystery into territory. When man speaks of colonizing Mars, he believes he is bringing life to another planet. In reality, he is carrying his own shadow there. What threatens Mars is not physical contact with Earth. It is the psychological reflection of humanity imposing itself upon the cosmos. Man carries Mars within himself, and it is this inner contamination that may destroy everything we touch. Since the first rocket was launched, space conquest has been presented as a triumph of human reason. Yet beneath the glow of technological progress lies an older impulse: the desire for absolute control. The same impulse that felled forests, drained oceans, and burned atmospheres now sets its sights on space. Mars is the new frontier of that ancestral instinct, the new mirror upon which we project our need to conquer. Every mission, every probe, every colony project is, at its core, an attempt to prove that humanity is greater than its own limits. But history proves the opposite. The more we try to dominate, the more we destroy what we touch. The inner danger manifests in subtle ways. It appears in the arrogance of those who believe they can improve a planet, in the impatience to transform the unknown before understanding it. It hides within speeches of hope that mask escape, the promise of a new home for a humanity that has yet to learn how to care for the old one. The desire to go to Mars is born more often than not from courage, but from fear. Fear of extinction, fear of failure, fear of facing our reflection in a dying Earth. Instead of changing our habits, we prefer to change worlds. It is the ultimate flight, not from death but from responsibility. To carry Mars within is to bring into space the same mental structures that shaped terrestrial civilization. The logic of competition, possession, and extraction. The belief that everything can be exploited, purchased, and molded. That is why the danger of Mars is human. Even if we never set foot upon its soil, we have already contaminated it with our desires. Every terraforming plan, every speech about saving the species, echoes the same tone of conquest that marked the ancient empires. And like every empire, humanity's empire in the cosmos is born from the illusion of eternity. This danger runs deeper, because it does not depend on technology, but on consciousness. We may build perfect ships, raise colonies, and construct gleaming domes on Martian soil, yet if we do not change what we are, we will repeat the same mistakes. Humanity carries not only its biology, but also its morality. its history, its imbalance. And it is this imbalance that threatens to turn every new world into a repetition of Earth. There is no distance far enough in the universe to escape one's own nature. In that sense, Mars is more of a mirror than a destination. It forces us to face what we have become, a civilization that searches for life on other planets while killing it on its own. We seek silence in the cosmos, but ignore the cries of nature here. We speak of preserving humanity, but forget to preserve the human. And the human, in its essence, is made of connection, not conquest. The inner danger is also philosophical. As we carry our presence into space, we bring along our questions. Who are we to alter the universe? What right do we have to manipulate environments we barely understand? Science can answer the how, but it rarely questions the why. To colonize another planet, without first understanding our inability to coexist, is to repeat the same mistake on a cosmic scale. Man, in his hunger for immortality, forgets that the universe does not need him. If there is anything to fear on Mars, it is not the unknown, it is the known ourselves. Humanity is the only biological vector capable of bringing destruction to places where life has never existed. It is the only being that turns curiosity into control and progress into possession. And as long as we fail to recognize that paradox, every new planet will be only an extension of the old one. To carry Mars within oneself is, ultimately, to understand that the true danger of space exploration lies not out there, but within. The universe is not an enemy to be conquered, but a mirror to be read. Life expands not through domination, but through coexistence. Perhaps the real step toward the stars is not a technical one, but a spiritual one. The moment when humanity stops seeing the cosmos as a prize and begins to see it as a home. Because if we do not change what we are, no matter how many worlds we find, in all of them, we will keep carrying the same desert within us. The true horror of the universe does not lie in its infinite distances, its frozen deserts, or its radiation-filled abysses. The horror lies in man, in the way he carries within himself the very impulse that destroys him, and yet calls it progress. The danger is not Mars. The danger is the human being trying to multiply across the cosmos with the same mentality that has already exhausted his own home. For it is not space that threatens Earth. It is Earth that threatens space, embodied in the figure of man who has not learned to exist without domination. From the dawn of history, humankind has moved under one conviction, that everything which exists is at its disposal. First came the forests, then the seas, then the very climate. Now it is the universe. Every technological advance is presented as liberation, but in essence, it is the expansion of the same instinct for possession. The colonization of Mars, wrapped in speeches of hope, is merely the new face of an old ambition, to leave our mark wherever there is emptiness. But the universe does not need human marks. It is already complete in its own harmony. Man speaks of taking life to other planets, but rarely of taking wisdom. He speaks of building, but not of understanding. He speaks of survival, but not of coexistence. This lack of humility is what transforms the cosmic dream into an ethical nightmare. For in trying to multiply, man is not spreading life, he is spreading his own disorder. It is the infinite repetition of the same story. To arrive, to exploit, to exhaust, and to leave. The only difference is that now the stage is no longer a continent. It is the entire cosmos. And there is a tragic irony in this. Humanity reaches for space in the name of survival. Yet what threatens its survival is exactly what it carries within, the inability to live without destruction. In every rocket launched lies the same impulse that burned forests and poisoned oceans. What we call the expansion of civilization may in fact be the expansion of human entropy, emotional and ethical chaos spreading like a luminous plague among the planets. But perhaps the universe possesses a kind of wisdom that man does not yet understand. Perhaps the void between the stars is the antidote to arrogance, a silent reminder that life is not the center of anything. Mars, with its silence and vastness, confronts us with this truth. We are not gods ascending, rather we are temporary passengers in an indifferent cosmos. And perhaps it is that indifference that humanity fears most, the realization that the universe can exist perfectly well without us. The danger of trying to multiply across the cosmos is not only physical destruction, but symbolic destruction. If we carry human arrogance to other worlds, we will not only be changing the chemistry of planets, but also the meaning of the universe itself. Every colony built would be an attempt to domesticate the infinite, to turn mystery into property. The same civilization that turned the blue of Earth into smoke would try to turn the red of Mars into green, the silence of moons into noise, and the darkness of stars into artificial light. Man would erase the cosmos in his attempt to illuminate it. But there is an alternative, a form of multiplication that does not destroy but awakens. It is the multiplication of consciousness. Instead of expanding bodies, we can expand perception. Instead of carrying machines, we can carry wisdom. Humanity's true future does not lie in spreading its matter across the universe, but in understanding its place within it. The human species does not need to conquer the cosmos. It needs to learn to listen to it. The universe does not call us to conquest, but to contemplation. Mars is not a destination, it is a warning. It shows us what happens to a world that loses its balance, that dries, that silences itself. And if mankind truly wishes to survive, it must understand that the cosmos is not a mirror for its vanity, but a silent teacher, revealing the art of existing without domination. Because in the end, what threatens the universe is not microorganisms, nor radiation, nor the vacuum. It is the human being himself, trying to fill infinity with his own presence. The cosmos does not need more inhabited worlds. It needs a species that finally learns not to destroy the ground beneath its feet. And when that lesson is understood, perhaps man will look upon Mars and upon himself, and finally realize the danger was never out there. It was always within. The universe, in its vast and silent immensity, seems designed to prevent contact. The distances between worlds are so immense that even when life arises, it exists isolated within cosmic bubbles of time and matter. But humanity, incapable of accepting isolation, decided to break this barrier. Probes, modules, and future colonies are not merely technological achievements. They are the first gestures of touch between two worlds, and every touch, no matter how gentle, alters what is touched. The meeting between Earth and Mars will not be only scientific. It will be biological, chemical, and spiritual. And like every encounter between distinct forms of life, it will bring both revelation and danger. Imagine the moment when the first fragment of Martian soil is brought to Earth. In an isolated laboratory, under white light and absolute silence, a small red particle rests on a glass slide. Scientists observe through microscopes and sensors, searching for movements, reactions, or signs of metabolism. And if, at some point in that process, a molecule reacts, a structure vibrates, a protein shifts, that instant will mark the first biological contact between two planets. There will be no fireworks, no speeches, no hymns, only the nearly inaudible sound of the cosmos touching itself. But this touch is ambiguous. Every form of life carries its own chemistry, its own molecular balance. And when two biochemistries meet, the result can be harmony or destruction. On Earth, we have seen it thousands of times. Invasive species erasing ecosystems, viruses crossing species barriers, molecules combining to form unpredictable toxins. Now imagine the same phenomenon on a planetary scale. What happens when the metabolism of one world meets the metabolism of another? When unknown enzymes interact with human proteins? When alien microorganisms, even dormant ones, encounter Earth's oxygen? Planetary quarantine protocols exist precisely to prevent this scenario. Yet deep down, they are merely attempts to contain the inevitable. The contact between worlds is not a question of if, but when. Every sample returned, every probe that comes back, every microorganism that survives radiation, represents a bridge between biospheres. And once such bridges are built, they can never be fully undone. Even if no life exists on Mars today, the very act of exploring it creates conditions for terrestrial life to invade, and that alone is a kind of biological encounter. There is also a deeper dimension, the symbolic encounter. When Earth touches Mars, it is life itself touching the unknown. The same principle that once made the ocean meet the sand for the first time. That gesture contains beauty, but also tragedy, because every expansion implies loss. The touch that unites also contaminates. The embrace that connects also transforms. Life is, by nature, invasive. It does not ask permission, it settles. And when two living worlds meet, the result is always fusion. never pure coexistence. Perhaps the encounter between Earth and Mars will reveal something we never expected, that life is a more universal phenomenon than we imagined, that there are no boundaries between terrestrial and alien biology, only variations of a single cosmic melody. In that case, the contact would not be destructive, but illuminating, a reunion of separated fragments from the same stellar origin. But if instead their biochemistries prove incompatible, the meeting would become a collision, a molecular clash between two systems that were never meant to touch. Either way, contact is inevitable. Humanity can build barriers, domes, and laboratories, but it cannot stop curiosity. The desire to understand the cosmos is the engine of life itself, and paradoxically, it is that same desire that can endanger everything we know, because the universe does not separate life from death, creation from destruction. It merely transforms one into the other. There is something poetic in that destiny. The first contact between worlds may also be the last breath of one of them. But perhaps that is how the cosmos grows, not by expansion but by encounter. Every collision, every fusion, every molecular exchange is a new form of existence. Life does not fear contact, it seeks it. It is we who fear the reflection it brings. In the end, when two biological worlds finally touch, it will not be Earth touching Mars, nor Mars touching Earth. It will be the universe itself touching its own reflection. And in that instant, perhaps we will finally understand that we are not explorers or conquerors, but temporary messengers of a life endlessly trying to recognize itself among the stars. There is something profoundly symbolic in the idea of the first contact between Earth and another world. For centuries, humanity has dreamed of finding life beyond its planet. Ancient civilizations, lost intelligences, beings made of light or dust. But the universe, in its silent irony, may have reserved for us a destiny far more modest and far more tragic. The first contact not as a celebration but as an epitaph, because the first touch between two worlds could also be the last breath of what we call terrestrial life. Picture the scene. A capsule returns from Mars carrying carefully sealed samples. Inside a sterile laboratory, scientists in pressurized suits observe the material. Nothing moves, nothing pulses, only the mineral silence of an ancient world. But life, if it exists, does not need to move to act. One molecule, one remnant, one fragment of a dormant protein would be enough to begin the process. And that process would not be war nor invasion. It would be something far subtler, like a wrong note in a perfect symphony. The terrestrial biosphere, upon contact with what came from beyond, would begin to vibrate at a different frequency. Microorganisms would react, chemical chains would reorganize, enzymes would find new paths. The Earth, without noticing, would begin to change. This is the supreme paradox of science. The closer we come to the origin of life, the greater the risk of destroying it. The first contact, awaited as the ultimate answer to the mystery of existence, could also be the turning point, the moment when what we are begins to unravel. Not because of Mars nor because of microorganisms, but because of human curiosity itself, the urge to know more than we should. Absolute knowledge is a form of extinction because it dissolves the mystery that sustains life. From a cosmic perspective, perhaps it makes sense. Life, anywhere, is merely a temporary organization of matter. When two biological systems meet, what happens is not destruction, but transformation. The first contact could be the last breath of terrestrial life, but also the first breath of a new form of existence, a fusion between the biology of Earth and that of Mars, creating something that belongs fully to neither, a new planetary species, hybrid, unknown. Life, after all, does not care about borders, it only continues. But for humans, who build meaning upon the fear of death, such continuation offers no comfort, because losing what we are feels the same as dying. And perhaps the final destiny of terrestrial life is not to vanish, but to dissolve into the cosmos, to scatter as living dust among the worlds, until no distinction remains between beginning and end. In that sense, the first contact is not the end of life. It is the end of humanity as we know it. This metaphor, the first touch as the last breath, is also a philosophical lesson. It shows us that the universe has no preferences, makes no distinction between creation and destruction. What to us seems tragedy to the cosmos is simply continuity, and perhaps the purpose of existence was never survival, but return, to return to what we came from, to stardust, to primordial chemistry, to silence. The first contact with Mars, therefore, would be a kind of reconciliation, the reunion of life with its own beginning, a cosmic circle closing upon itself. There is a melancholic beauty in this vision. Humanity, which spent ages trying to escape death, might find immortality not in prolonging its species, but in dissolving into vastness. The end of terrestrial life would not be defeat, but surrender, because, at its core, everything that lives belongs to the universe, and the universe always reclaims what is its own. Perhaps the final act of humanity will not be catastrophe, but silence. A silence so deep it will echo for ages. In that silence, terrestrial life will become something else, something free of our fears, our boundaries, our arrogance, and the universe, indifferent, will go on turning, as it always has. And so, when the first contact finally happens, there will be no fear, no joy, no victory. There will only be the sensation of return, the cosmos touching itself, life recognizing the mirror from which it was born. And Earth, in its final breath, will finally understand that it was never alone. It was only waiting for the moment to go home. There will be an inevitable question once the silence of the first contact has faded. What will humanity leave to the universe after it disappears? This question goes beyond biology, beyond science, beyond philosophy. It is a question about legacy, not in the sense of buildings or monuments, but in the sense of what truly persists when the body of a civilization no longer breathes. Earth, with all its history, its art, its errors and discoveries, is a living scar on the fabric of the cosmos. And when contact with another world is complete, part of that scar will spread forever, turning humanity into cosmic memory. Even if humans vanish, what they created will continue to exist in fragments. Lost probes drifting through space, messages etched onto golden records, radio noise traveling through the vacuum like echoes of an ancient voice. These small presences are the technological fossils of terrestrial civilization, traces left in infinity by a species that wanted to be remembered. It's possible that one day no conscious life will remain on Earth, yet a shard of metal or a radio signal will still cross the borders of the solar system. And that in some way will testify that we existed. But there is something deeper than material inheritance. Humanity's true cosmic legacy is the act of looking up. Curiosity is the trait that defines our species more than any other capacity. We are essentially seekers, creatures who look at the unknown and ask why. This impulse to explore, even when destructive, is also the spark that connects us to the universe. Because curiosity is the cosmos's consciousness reflecting upon itself. And no matter how tragic the ending, that gesture is eternal. If contact with Mars marks the end of terrestrial life as we know it, it will also mark the beginning of something larger, the fusion between the human and the cosmic. What we were, our biology, our culture, our history, will merge with the universe. Every particle, every molecule crafted in laboratories, every human cell transformed by interplanetary travel, all will become part of the greater cycle of existence. Humanity's legacy, then, will not be a preserved civilization, but an influence, a subtle perturbation in the cosmic balance, a chemical and symbolic signature in the fabric of reality. Perhaps this is how the universe remembers us, not with statues or memories, but with reactions, an enzyme that survives in Martian soil, a synthetic compound spreading through rocks, a new hybrid life form born of contact. Even if humanity disappears, its presence will persist in microscopic structures, in particles, in atoms. We will be, quite literally, part of other worlds. There is, however, also a moral legacy, one the cosmos may not need, but one we must understand. How we treat Mars will reveal the kind of species we were. If contact is destructive, if we bring extinction instead of knowledge, our legacy will be that of cosmic predators. But if we can touch another world with respect, with caution, with reverence, we will leave a different mark, that of a species that, for an instant, learned to look without needing to possess. The future will remember humanity not for what it built, but for how it understood what existed beyond itself. This reflection leads to a quiet conclusion. Humanity's legacy will not be judged by the universe, but by its own conscience. The cosmos has no morals or preferences, it simply is. It is up to humans to decide whether they wish to be remembered as noise or as harmony, as destroyers or as observers. And in the end, perhaps that will not matter to the universe, but it matters to us. There is an almost tragic beauty in this notion, because even knowing that the universe will remain indifferent, humans still wish to leave something behind. That insistence proves that, despite all arrogance and destruction, there is something profoundly pure within us, the desire to mean. And it is that desire, more than our feats, our technologies, or our colonies, that will be our true cosmic legacy. When the final contact happens and Earth falls silent, humanity will not entirely disappear. It will endure in the molecules it sent, in the signals that echo, in the ideas that drift among the stars. It will endure above all in the ancestral gesture of those who looked at the sky and dared to ask what lay beyond. And even if the answer was silence, it was the question that made us immortal. The silence of the universe is not emptiness. It is respect. It is the interval between what we can understand and what we are not yet ready to know. And perhaps this is the greatest lesson that Mars and the cosmos as a whole offers us. Life beyond Earth may exist, but perhaps it should not be touched. Human curiosity is a powerful flame, but also a blind one. It illuminates the path of knowledge, even as it consumes what it illuminates. And there are moments when wisdom consists of not lighting that flame, of simply looking, admiring, and letting the mystery exist. Throughout history, humankind has confused discovery with possession. Each time it found something new, it wanted to shape, study, and dominate it. Now, faced with the vastness of the cosmos, that attitude becomes dangerous. The universe is not a laboratory, it is an organism in balance. To interfere with it is like moving a single cell without understanding the entire body. The simple act of touching can destroy what took billions of years to form. Life, if it exists on Mars, is silent testimony that the cosmos is fertile by nature, and for that very reason it must be preserved. The idea of not touching may sound contrary to the essence of science, but it is in fact its highest form. Curiosity requires ethical limits, just as power requires conscience. Progress without reverence is merely sophisticated vandalism, and perhaps the greatest act of intelligence humanity can offer the universe is the humility to step back, to understand that not everything that can be done should be done. Science must seek truth, but truth sometimes demands silence. Mars, with its cold desert and arid beauty, reminds us that the cosmos does not exist to serve humanity. It exists to be contemplated. The true value of exploring other worlds lies not in transforming them, but in learning from them. Every grain of Martian dust is a particle of time, a fragment of cosmic history. To touch it without understanding is to desecrate the sacred, because the sacred is not divine in the religious sense, but untouchable, that which must be preserved so it can continue to teach. Life beyond Earth, if discovered, will not be a prize or a conquest. It will be a mirror, a reflection of the same principle that created us, showing that existence is a work far greater than our imagination. And perhaps that mirror is not there to be studied, but to remind us who we are. The universe does not need our intervention. It needs our respect. There is a kind of wisdom that can only be born from silence. And space is absolute silence. In it, life spreads like a secret the cosmos whispers to those who know how to listen. Perhaps we should learn to be listeners, not invaders, because life, wherever it exists, is part of the same fabric. And if we destroy one thread, we weaken the whole. Humanity has spent millennia trying to understand the universe, but perhaps the universe has only one message for us: observe, do not possess. That is the true cosmic ethic. And if we learn that lesson, there may still be hope that the human touch will not always mean destruction. In the end, the story of Mars is not about a distant planet. It is about us, about how we deal with the unknown, with difference, with the power to create and destroy. It is about the possibility that humanity's greatest achievement is not colonizing another world, but understanding its place in this one. Life beyond Earth may exist, and perhaps, somewhere in time, it observes us as we now observe it. But if we are wise, we will never need to touch it to know it is real, because understanding is sometimes the same as allowing to live. And perhaps that is the true end of the journey, not the human step upon another soil, but the moment when we finally learn to remain still before infinity, in silence, with respect, and with gratitude. At the end of all human journeys there is always silence, the same silence that existed before the first word, before the first fire, before the first gaze lifted toward the sky. And it is within this silence, dense, deep, almost sacred, that the story of life on Earth may find its conclusion. Because the first contact, long awaited as the greatest triumph of science, may also be the last breath of what we call terrestrial life. Not as a sudden disaster, not as an explosive apocalypse, but as a slow and inevitable fading, the moment when two biochemistries touch and the universe rewrites its laws. The touch would be microscopic, invisible, without sound or light. No scream would echo, no catastrophe would be recorded, only a minute reaction, a structural deviation, a new chemical path that was never part of life's plan. And from that moment on, everything would change. The Earth would begin to breathe another kind of air, an air that does not recognize what we once were. That would be the final destiny of human curiosity, to dissolve into what it sought to understand. Humanity, which spent ages dreaming of touching the stars, would end up fused with them. Life on Earth, in its final act, would not vanish. It would simply become something that could no longer be called us. And perhaps it would be fair that it should be so, because the universe never promised eternity, only continuity. And continuity always demands that something die, so that something else may be born. Yet there is beauty in that ending, a kind of melancholy and inevitable beauty, like that of a flame that fades not from weakness, but from having fulfilled its purpose. The first contact, then, would cease to be a scientific event and become a cosmic ritual, the fusion between creator and creation, the reunion between life and the stardust from which it came. The last breath of Earth would also be the first breath of something new, a form of life that belongs not to any planet, but to the universe itself. Perhaps when that moment arrives, there will be no witnesses, no human being left to tell the story, no names, no memories, but the gesture will have been made, the gesture of touching the infinite, of looking into the abyss and, despite fear, reaching out a hand. That gesture defines humanity more than any other achievement, and that is why, even in the end, there will still be dignity. The final breath of life on Earth will not be a failure. It will be a return to the origin, to cosmic dust, to the primordial silence, a return to what we have always been, brief fragments of consciousness floating in the ocean of time. The first contact and the last breath are, in truth, the same instant, the point where curiosity meets eternity. And when the universe, in its infinite calm, absorbs the echo of that breath, perhaps it will smile, not with a mouth, but with stars, because it will understand that for one brief moment, life on Earth dared to do what no other form of matter had done before, to look at the cosmos and try to understand it. And that in itself was enough to justify existence. Now, the sound of the wind blends with the distant echo of our own breathing. The world slows down, the heart of the Earth beats softly, and the universe seems to lean over us, not to answer, but to listen. Here ends the story of humanity's search for Mars, and perhaps begins another far deeper, the story of a planet that sought to understand its own reflection. Because, in the end, this is not a story about space. It is a story about us, about the inability to accept mystery, about the fear of disappearing, about the insatiable desire to turn the unknown into something we can control. Humanity has spent millennia breaking boundaries, maritime, aerial, atomic, and now cosmic. Each conquest seemed to bring us closer to immortality, yet paradoxically pushed us farther from what truly matters. What we forgot is that true greatness never lay in mastering what is outside, but in understanding what is within. Mars is not the enemy, it is the mirror. It shows what we could become if life ever ceased within us, a planet that was once alive and now breathes only in silence. Perhaps the most important lesson of the cosmos is also the simplest. Some things must remain untouched, not out of fear, nor out of weakness, but out of reverence. Life, in whatever form it exists, is a fragile and rare miracle, too sacred to be handled with arrogance. When we look at Mars, we should not see a potential colony, but a reminder the portrait of everything we stand to lose when knowledge walks without conscience. The universe is vast, ancient, and patient. It does not need conquerors. It needs humble observers. Science, when practiced with respect, is prayer. It is the act of looking into the unknown and saying, I exist, but I know I am small. That is the essence of true scientific thought. Not domination, but contemplation. And perhaps when humankind finally understands this, the cosmos will welcome us not as invaders, but as part of itself. So as you hear my voice slowly dissolve into the sound of the rain, imagine the universe out there. Infinite, silent, alive. Think that every star shining in the dark is a reminder that we are part of something far too vast to fit into words, and that the greatest act of wisdom may simply be to remain silent before the mystery, because perhaps the first contact does not need to happen between planets, but between humanity and its own consciousness. Perhaps the true encounter is this one, the moment we finally understand that the cosmos never needed to be conquered, only understood. Now close your eyes, take a deep breath. Let the sound of the rain erase the boundaries between you and the universe. The distant cold of Mars, the warmth of your body, the rhythm of your heart, all are the same fabric, the same vibration. You are made of the same particles that shine within the stars. And when the silence arrives, there will be no end, only continuity. Good night, traveler among the stars. You are in the cosmos, and the cosmos is in you, before the silence of the universe takes over once more. Tell me something. Where are you listening to this journey from tonight? From your dark room in some glowing city? From a quiet farmhouse under the sound of the rain? Or maybe from a little corner far away from everything, where the sky feels closer and time walks slower? Write it down in the comments. I want to know how far this voice of the cosmos is reaching. It's amazing to imagine each of you scattered across the world, listening to the same rain, sharing the same silence among the stars. And if this journey made you think, soothed your mind, or awakened your curiosity about the infinite, leave a like. Subscribe to the channel and turn on the bell to keep traveling with us. Here, every night is a different crossing between science, mystery, and the sound of the universe falling asleep with you. Good night. Wherever you are, may the stars light your dreams and may the cosmos find you in peace.